Hi guys, let's see this new video for convex hull. In this video, first of all, we'll understand what is convex hull, and after that, we'll see how to make a convex hull construction. After that, we'll see its code. I'll code in the video, right, from the scratch, and after that, we'll solve a question based on convex hull. It's named Polygon on Codeforce. So let's get going with this convex hull. So convex hull is a very simple topic, and actually what is a convex hull? That if we are given various points on a 2D plane, and if I stretch a rubber band, right, if I stretch a rubber band outside these points, let's say this is the rubber band, and when I leave this rubber band, I stretch the rubber band, and when I leave it, then this rubber band will stuck on some points, right, will catch these points, right, these points. So basically, okay, so basically these points are a convex hull. Okay, so basically these points form a convex hull. Okay, so what does a convex hull mean? That if I want to cover all the points, then there will be a polygon formed in the outer parts of these points, right? So all these points will be covered inside the polygon, and that polygon consists of points which will form the convex hull. Okay, basically convex hull is a set of points which forms a polygon. We'll see its properties. Okay, and when this will form a polygon, then all other points, right, all the points, remaining points, will lie completely inside that polygon. That's why it's called a convex hull. Okay, it means the outermost boundary of the points, right? So let's see one more thing here. Why is it named convex, right? Because guys, you can see this, that all the angles of this polygon will be convex. Why? Let's say I have 3 points, and when I stretch a rubber band and leave, then this will be my convex polygon, right? You can see all the angles are less than 180, right? Now just imagine that there are these points and there's one point inside. So guys, this forms, this angle is not a convex angle, right? So therefore what I'll do is, if I only take these 3 points, then we can see there's one more polygon formed, right? So at any point of time there will be no angle which will be greater than equal to 180 degrees, right? So there will convex hull will always form convex polygons, right? So okay, now let's take one more case. So what we have done, I hope you have got the idea of convex hull, what convex hull is. Now let's see how to construct the convex hull. Okay, so we'll construct the convex hull by using an algorithm called Graham-Samp algo. Okay, so let's discuss this algo. I'll discuss a slightly better approach of this algorithm. There are various other approaches too. Okay, I hope you'll pay attention to this. Let's say this is a 2D plane. So initially what I'll do is, okay, I'm just marking some points. Okay, so guys, there's one thing to note in this, that the leftmost bottom point, this point, and the rightmost top point, these points will always be included in the convex hull, right? Why? Because when I'll stretch a rubber band, then this rubber band will always pass through this point and this point. It's intuitive, right? So these 2 points will always be considered inside the convex hull. So what I'll do initially is I'll sort all the points. Okay, I'll sort the points on which basis? On the basis that if on the basis of x coordinates first. Okay, and if x coordinates are equal, then on the basis of y coordinates. If x equals, right, let's say we have 2 points, and if a dot x equals b dot x, then what I'll sort them accordingly to the a dot y is less than b dot y. Okay, in first is the priority of x coordinates and the second priority is of the y coordinates. So guys, what I'll get, my first point, that the point 0 in my array after being sorted will be the leftmost lower point, right? Why? Because I have already sorted them on the basis of x coordinates, right? Then after that I'll sort them on the basis of y coordinates. So guys, my last point, that will be p of n minus 1. Let's say there are n points. Okay, so p of n minus 1 will be topmost right point. I hope you got this point. I have just sorted all the points on the basis of their x coordinates and otherwise the y coordinates if x coordinates are equal. So guys, this point 0 is my leftmost point, and p n minus 1 is my rightmost point. Okay, now let's see further steps of this. So guys, let's mark this point as p1 and let's mark this point as p2. So what we'll do is, if now I'll divide all my points into 2 sets. Let's say the first set is up and the second set is down. Okay, why am I doing so? We'll discuss. Let's say this is the line joining these 2 points, right? So now all the points above this line are in my set called up, and all the points below this line are in my second set called down. Okay, so I will make a different convex hull from going this way, right, to this point. I'll start from p1 and I'll start going. I'll make a convex hull and go to p2, right? And in a similar fashion, in the downside, what I'll do is I'll start going from this way, right, and similarly I'll reach p2. So I'll have all the points of the convex hull of the upside, right, and I'll have all the points of the convex hull of the downside. Okay, and now we'll discuss how we'll make the convex hull, but I hope you're getting this point. I'm making 2 convex hulls after partitioning the points into 2 different sets. Okay, so let's see the further approach. Now guys, what I'll do is initially I'll put this point p1 in both the sets, up also and down also, right? Okay, there's one small point that we need to discuss. Let's discuss it quickly, and I know you know that point, but let's discuss it again. If I want to find that let's say we have 3 points a, b and c. Okay, and I have to find that when I go from a to b and then I go from b to c, I just need to calculate that whether I make a left turn. What does left turn means? Counterclockwise, right? And what can be the second option? That when I go from a to b, bc, right, and then I go in the right turn. What does right turn means? Clockwise. Okay, so there are these 2 things, that if I pass points a, b, c, and then my function will return whether I'll go counterclockwise or whether I'll go clockwise. Okay, so how to calculate this? What is my orientation of the points, right? That's called orientation. So what will be my orientation of these points? How will I calculate this? Let's say this is the point a and this is the point b, and let's say this is the point c, right? So guys, we can see that this slope, let's mark this angle as alpha, and this slope, let's mark this angle as beta. Okay, beta. So this alpha and this beta, what can we notice? That beta, if alpha is less than beta, then I am making a left turn. What is that? It's counterclockwise, right? Going against the clock. And if I make a right turn, then what will be my condition? This condition is for counterclockwise. Okay. And if alpha is greater than beta, what does this mean? That this angle was big and then this angle was small, right? So what is this case for? It's for a right turn, that is a clockwise direction. So this is the case for a clockwise direction, right? So guys, it's very easy to calculate this slope of two lines and then calculating whether alpha is less than beta or not, right? How? Let's say the points are ax, ay, bx, by, cx, cy. Actually, I'm going slow in this video because I want you to understand it properly. What does convex hull means and how to implement the whole code, right? So what's my alpha? Alpha is by minus ay upon bx minus ax, right? And what's my beta? Beta is cy minus by upon cx minus bx, right? If I want alpha to be less than beta, then what is the condition? I'm just performing some maths here. Okay, by minus ay upon b minus should be less than beta, right? X minus cross multiply and devise a short formula for this will be by cx minus bx by, right? Minus ay cx and plus ay bx less than bx cy. Okay, this is minus bx by, right? Minus ax cy and plus ax by. So this is the equation, and when I'll take all the values on the left side, I'll get that ax into by minus cy plus bx into cy minus ay, right? I'll just what can we say, just cut some values that are repeating, that we can see this will cut from this, and then I'll take some common values, right? bx cy minus ay plus cx ay minus by, it should be less than 0, right? If I provide 3 points to a function and I ask that whether it is clockwise or counterclockwise, then if this is less than 0, then it is, we discussed above, right, counterclockwise. And if this value is greater than 0, then it is clockwise, right? And if this value is equal to 0, then it's collinear. The points are collinear. I never made a left turn and I didn't make a right turn, right? Why? Because this will be equal to this, so these two angles will be equal and subtraction of these two angles will be 0. Okay, I hope you got this. So let's move forward into my convex hull algorithm. These were two small topics that we discussed right now. Yeah, now let's get going with these points. Okay, now what I'll do is I'll iterate in the array. Now when I am at a point p1 and I want to find out that whether the point, a particular point, let's say pi, whether a point pi is in upper half or lower half, then what I can do is, right now I explained this to you, that if we want to find out whether the point is in the upper half or the lower half, then what we can do is simple, right? If from p1 I go to that point and make a right turn to p2, right, means the orientation of p1, pi and p2, right, if this is clockwise, then it's in the upper half, right? And if the orientation is this way, then it's in the lower half. Okay, so if the orientation is counterclockwise, it's in lower half, and if the orientation is clockwise, it's in upper half. I hope this small thing is clear to you, right? So by checking this thing, the orientation of this point, I can easily check whether the point is in the upper half or the lower half, right? Now let's move forward with this approach. So guys, let's see one thing, that I'll be using stack in this. Why am I doing so? I'll explain it to you. So let's say this is a point P1 and this was the recently discovered point, okay? And if I get a point, I'm talking about the upper half right now, okay? If I get a point, some, let's say P2 and P3, okay? So guys, will this point P2 be considered in the convex hull? No, na? Why? Because when I go to P2 and then I go to P3, this makes a left turn. So if I'm talking about the upper half, right, and if I make a left turn, then this point should not be included. P2 should not be included in the convex hull. Why? Because we can go from P1 to P3 directly, right? Because rubber band won't come to P2 inside. So whenever I'm going in the upper half, right, if I go to this point and I go to this point, then this point won't be included because it's making a left turn to some other point. So directly this will come in my convex hull, right? I have to remove this. Similarly, in the lower half, what will happen? Let's say this is a point and this is my second point and this is my third point. Again the same thing, right? Just opposite. What is it? That if I move from point P1 to P2 and then I move to point P3, which makes a right turn, then P2 won't be included in my convex hull. Why? Because I can go from P1 to P3 directly, right? So the rubber band will come this way, right? So I hope this point is clear to you. If I go to a point and I go to some other point by making a right turn in the lower half, then I will just pop this out, okay? And I'll keep popping the elements until I make a right turn, right? So let's say first I included point P1, then I included this point, then I included this point, right? But now I get a point this, right? So what will happen? I'll first of all pop this point. Why? Because I'm making a right turn. So now this is not in my convex hull, okay? I remove this. Now again I'll check. So again I am making a right turn, okay? Then again what I'll do, I'll just remove this point from my convex hull and I'll add this final point in my convex hull, okay? So the main thing is that if I'm in the lower half, then I'll have to remove a point. Why? When it makes a right turn to some other points, okay? And when I'm in the upper half, I'll have to remove a point. Why? When it makes a left turn to the upper half, okay? Because in the upper half I can directly join this and in the lower half I can directly join this. So when I'll code, it will become more clear. I'll again explain this, okay? But before that, you should watch above two videos also for the convex hull. Now let's see, let's talk about further approach. Actually this was the main approach of the convex hull, that about the clockwise and counterclockwise positions of orientations of points, right? So whenever I'm in the lower half and I make a right turn, I'll just pop the middle element because I don't want that element in my convex hull, okay? Now there's one more thing that we need to discuss, that let's say we have a straight line. Of course this is not a convex polygon, okay? Let's say we have 3 points and that are collinear, right? And why am I talking about this case? In most of the times you won't need to face this case because it will be already be given that no 3 points are collinear. It will be mentioned in the question, right? But there's this question on lead code called erect the fence. In that question there's a test case in which the points are collinear, right? So let's talk about this case. So when I'll make my convex hull, first I'll insert P1, right? And then I'll go to P2. I'll have to insert this, right? And because I'm taking the collinear points, and then I'll again insert this point. So in my upper half I'll have point P1, point P2, point P3, right? And in the lower half also I'll have point P1 and point P2 and point P3. So guys, we can see the points are repeating, right? So what I'll do is, my final convex hull will be the points of the lower half union points of the upper half. Why am I doing union? Because there are few points that will be repeating, right? So it's about a linear case, but when I have other cases also, then also there will be few points that would be repeating, right? So what I'll do is I'll simply just sort all my points, and then what I'll do, I'll make them unique all points. Okay, now what I have all my points in the convex hull, and I have made them unique. I don't have to worry about this case anymore. Okay, so guys, let's code this. So guys, this is my basic template. Okay, the header file and some defines, not much a big deal. And this is a function, it will just help me copy from this input and paste in this output. Okay, and then let's try to code convex hull, right? So initially I'll have few points. Let's take some points and make our own case. So let's make some points. Let's say the points are 0 0 1 0 1 1 0 0 1 0 1 1 1 2 0 2, and what's this point? Yeah, 0 1. Okay, so we have these 6 points and this makes a rectangle. Now let's find the convex hull of these points. Of course the convex hull will include all these points, right? I'll take further more cases and we'll discuss again. So let's make a case. 6 points, 0 comma 0 0 comma 1 1 comma 0 0 comma 2 1 comma 1, right, and 1 comma 2, right? These are my 6 points, and let's input them. Okay, let's make a structure called point. We'll be using it again and again. It will have two values, x comma y, the x coordinate and the y coordinate. Make a vector, and in the vector I'll just push back these points. Point, say v. Okay, now okay, let's make it p. Now let's run a loop from 0 to n, and what I'll do is I'll input the point, right? So guys, let's complete this code. So now what I'll do is I'll make a function called convex hull, right, and I'll pass this vector p into it, and that function will actually change this vector into the points of the convex hull. Okay, convex hull vector points press p. Okay, because I need to change this vector, that's why taking it by reference. So if p dot size is less than equal to 2, then I'll simply return, because of course if there are only 2 points, then there's nothing to change in it. Okay, and now my third thing is as discussed, we need to sort this p vector of points. So if I want to sort it, I can send a comparator, or I can just overload the operator of this structure, right? So how do I sort it? As already discussed, if p dot x equals x, then return if y is less than p dot y, right? Else return x is less than p dot x. I hope this is clear to you, right? So I have sorted this vector p. Now after sorting it, we know the smallest x coordinate is the point p1, right? So actually p0 is p1 that I discussed, that will divide it into two sets, right? And p of n minus 1 is equals to p2. Okay, so let's take two variables, I and n equals to p dot size. and let's take 2 points that will divide it, p1 comma p2. Okay, p1 is equals to p0, okay, and p2 equals to p n minus 1, right? So what's happening here is actually p1 is bottom left point and p2 is top right point. That will divide all the points into two sets, right? Now guys, what can we do? Now let's forward. We just need to start from 1 and go to n and see in which half the points lie, right? So okay, let's see this in, yeah, as already discussed. I think it's discussed above that if it makes a, okay, is it discussed? And let's discuss it again. So if a point is a, let's say this is a p1 point and p2 point is here. Now p1 to p2, right, it divided points into two sets. So if I want to know the point is in the upper set, then what I'll do is I'll check if p1, that point in p2 makes a right turn, that is a clockwise angle, right? Or we can say not counterclockwise. Why am I saying not counterclockwise? Because it will include all the collinear case, right? So for that I need to write the two functions of collinear, right? So let's write those two functions which will tell me the orientation of the point. Let's say boolean clockwise, clock CW, clockwise, right? Let's say we have a point A and point B and point C. We are passing 3 points to it, and it will tell me whether point A, point B and point C are clockwise or not, right? So guys, the formula is already discussed here, this one. I'll just write this down. So it is what, if a dot x into b dot y minus c dot y plus b dot x into c dot y minus a dot y plus c dot x into a dot y minus b dot y, if this is greater than 0, right? Yeah, so if this is less than 0, then it is counterclockwise, and if it's greater than 0, then it is clockwise, right? So it is clockwise. Now for counterclockwise, what I need to do is just change it a little, right? And if I want to find if the point is collinear or not, then what I need to do is equals to 0. We have discussed this, okay? So right now I am currently at this position, and I have to check whether my current point is in lower half or upper half, right? So how will I check this? Already discussed, right? If this is the orientation of the current point and it makes a clockwise turn, then it's in the upper half, right? So if not counterclockwise, what's the point? P1 comma pi comma p2, right? This is the orientation I want. If this, I'm in the upper half, right? That means pi is in the upper half, pi is the upper half, right? And let me copy this for the lower half also. Again the same thing, if not CW, then pi is in the lower half, right? Not CW, what does this mean? That if, let's say this is here is a point and this is the angle, right? So what is this angle? It's counterclockwise. And here I told you that I'm considering collinear case, right? That's why I'm taking not counterclockwise and not clockwise, okay? Have you got this? Because not counterclockwise includes both collinear as well as counterclockwise, okay? I'm considering this case, right? So now I'm here. Okay guys, there's one more thing to see in this code, that for the point p2 should be in both the sets, right? Even in the upper set and in the lower set. Why? Because p1 is in both the sets. So p1 and p2 should both be in upper set also and lower set also. So what I'll do is, if I equals to I minus 1, then also it's in the upper set, and if I equals to I minus 1, then also it's in the lower set, right? Because P2 is the n minus 1th index. Clear? I hope this is clear to you. Now guys, what we need to do is, I just need to make a type of a stack, right? Okay, so let's make two vectors, and vectors can work as a stack. I'll show you how. Vector int, okay, point. We are playing in points right now. Up comma down. Okay, there are two sets. So what I'll do is, initially I'll push up. In up I'll push point P1, and in down also I'll push point P1, right? So these 2 points are pushed in up and down. Now what's the main theme here? I need to pop elements. Okay, let's understand this first, then we'll pop elements. So guys, assume this is the up vector. Initially the point here will be P1. Let's say P1 was here, and now let's say there is a point called P2 here, right? Not P2, P2 is here. Let's say it's A. This is P1. Okay, now this is making a this is not making any turn, so P will come in this vector, right? And after that, if I encounter a B, let's say it is B, so it will make a right turn, right? And which type of turn is this? It's clockwise turn. So for a clockwise turn, I don't need to do anything in the upper half, because that should be included in my convex hull. When will I want to remove an element from the vector? It will be when it's P1, right? And let's say this is a point A, and let's say this is a point B, right? So my vector currently contains point P1 and A. Okay, and make it properly. Yeah, now I'm going to a point B, and I check this orientation of point P1, A and B, right? P1, A, and the point that I'm currently on. So if this orientation is clockwise, anti-clockwise, then I need to remove this A from the vector. That means I'll just pop back A from the vector. I hope this thing is clear to you. So if I'm in the upper half, and if upper dot size is greater than equal to 2, right? And if I meet a counterclockwise turn of which points? What are these points? This is the last point of the vector, it is the second last point of the vector, and this is the current point I am going to check. So this is my first point, it's my second point, and it's my third point, right? It will be actually up dot size minus 2, right? Comma up dot size minus 1, right? Why? Because this is my first point, minus 2 1 minus 1 last point, and this is my current point. Okay, comma P of I. So if this while loop works, then I need to remove the current point. Then what I'll do, simply pop back. Okay, I'll just pop back the last point from the vector, and after this while loop is over, I'll simply insert the last point in the vector. Okay, same thing will be done for down, right? It's just a kind of vice versa type thing. Let me replace the names. Okay, if down dot size is greater than 2, and in this case here it will be CW, right? Why is that so? Because let's discuss it again. Let's say we have a point P1, and this is a point P2, and I'm going this way now, right? I am in the downside of the points. Okay, so let's say I make a point here, I meet a point here, that is A, and then I meet a point here, that is B. So we can see this will be included, but now when I try to make this angle, it takes a right turn. Right turn means a clockwise angle. So if it takes a clockwise angle, I will simply remove A, right? So just remove A. Okay, and in my convex hull, what will be my points now? Direct B connection. Okay, I'll remove A and I'll insert B. I hope this thing is clear to you. Okay, now this was a one-step case. You guys might be wondering why I have not taken if here, why I'm taking while here, right? So for that, let's explain this to you. Just say this is point P1 and this is point P2. Okay, now imagine that I'm at a point here, okay, and then I'm at a point here, and then I'm at a point here. Okay, So guys, this will be inserted, A will be inserted in my vector. Okay, earlier my vector was p1, this is about the down vector. Okay, then simply A will be inserted here. After that, let's say this is point B and this is point C. Okay, point B and point C. Now I'll check my P1 A and B, this angle. If P1 A and B, this makes a counterclockwise turn, then it's okay, right? I don't have to remove this. So B will be inserted, while loop will not work, right? But now guys, now see what will happen. Now my vector contains AB, P1 A and B both, right? So after this, B to C, there will be a right turn, right? From A, B and C, the next point is C, right? So there will be a right turn, and if there is a right turn, we all know, if I'm in the lower half and there is a right turn, I can directly make a connection this way, right? So I don't need B point. So what I'll do is I'll just pop back B from the vector, right? So let's pop it back. Now my vector contains P1 and A, right? Again I'll check the same thing, right? What? P1 A and C. Earlier I checked A, B and C, and I removed B from the vector. Okay, and now I'll check P1 A and C. Again the same thing, P1 A and C. So it's again making a slightly right turn. So what does this mean? That I can directly connect P1 to C. So I don't need this point A also. So again what I'll do in the same loop, what will happen? It will remove A also. Okay, so A will be popped out from the vector and C will be finally inserted. I hope this thing is clear to you, right? So A was not, earlier we included A, then we included B, then I popped them out again, and a point will only pop out once and insert once, at most once, right? So I hope this thing is clear to you, why I'm using a while loop there. Yeah, so let's move forward. So at this position here, my up and down vector contains all points, including the points P1 and P2 repeatedly, right? Okay, don't mention the spellings. Now guys, what will happen here, my up and down vector contains all the points, right? So let's make another vector, or what I can do is I can just clear the P vector. Okay, let's clear the P vector that I passed, and what I can do is I can just run a loop from 0 to right, and I'll just insert in P up I. Okay, I'll insert all the points in P. That means now actually I'm merging the up and down vectors. Okay, and do the same for the down vector also. Okay, now here my P vector contains all the points from up as well as, okay. So okay, now we know there are repeated points. So for that, what we can do is I can just sort the P vector and unique the P vector, right? So P dot resize, let's use inbuilt functions only. Unique begin to end P minus P dot begin. Okay, it's a simple function to unique all the elements. You can search about it on the STL page. Okay, so when I'll unique the elements, the unique property of a structure, it will check whether 2 points are equal or not, right? For that I need to overload an operator. Okay, point and P, what can be the thing here? If x dot, okay, x equals to P dot x, right, and y equals to P dot y, so the points will be equal. So let's try to build this. Now currently we are standing in this place. Now P contains all the points of convex hull. Okay, let's see if there are any errors in the code. Okay, there's a slight error. See, p dot y, p dot x. Okay. Okay, make it O then if p is not working. Okay, O. Yeah. Okay. Pull CCW. Okay. Counterclockwise, not clockwise, clockwise. Yeah, CCW. Okay. So we met a few errors and yeah, now it's fine. It's working. Now my convex cell contains all the points. Now vector P contains all the points of the convex cell. Okay. Okay. So as we saw for this case, this was the case, right? So convex cell of all these 6 points will be all the 6 points, right? So we are getting all the points. So guys, now let's check that whether we have made a correct code or not by submitting on the platform called Codeforces. Okay, so you can just pause this video, read this question, and then I'll explain the question and solve the question for you. Okay, so okay, I hope the question is clear to you now. So the question says that, let me make a snip. The question says that I have two convex I've got two polygons and the points are given. Let's say this is polygon A, okay, and I have a second polygon called polygon B, okay, and I have to tell that, okay, this should be a convex polygon. So these many points are not needed here. Yeah, it will work from these points. Okay, so this is my first polygon, that is polygon A, the convex polygon, right? You can see this is A, okay, and this is let's say we have 3 points here, and this is B. So B is in black and A is in white. So the question says that tell me if B lies strictly inside A or not. So we have to print yes or no, whether B lies strictly inside A or not. Okay, I hope this thing is clear to you, that whether B lies strictly inside A or not. Okay, what does strictly here means? That okay, let's take another example to make it clear. Strictly here means that if let's say this is a point 0 0 and I'm making the points of A, okay, and let's say this is point 4 comma 4 and this is a point 4 comma 0, okay, let's say this is a polygon, okay, and now see let's say we have a B polygon and its points are 1 comma 1, 2 comma 1 and 3 comma 2, okay, so it is 1 comma 1 here, 2 comma 1 here, and 3 comma 2 will be here, right? So this will be a polygon and this is a B polygon. So guys, we can see that B does not lie strictly inside A. Why? Because strictly means that every point of B should lie inside of the polygon of A, not even on the edge. I hope it's true. Okay, I hope you got it, that every vertex of B should lie inside, completely inside, not even on the edge of polygon A. Okay, so that's why I made a collinear case in this, that these 3 points will be collinear, right? So let's get on to the solution. It's a pretty easy solution to think. The solution is that if I include all these points, that is the points from A and points from B. Let me write the points from A. The points from A were 0 comma 0, 4 comma 4 and 4 comma 0, right? These were the points. So if I take a union of these points, that means now I have n plus m points, and if I try to make a convex cell of all these n plus m points, right? Then this convex hull should lie only on the boundary of A. Means all the points of A should be on this convex hull. If any of the point of B, if any point of B is on the convex hull of all these points, then B does not lie completely inside A. I hope this is clear to you. If B lies completely inside some A, then A should completely cover B, right? That means a convex hull of A should completely cover B. I hope this is clear to you. So what we'll do is we'll take all the points and make a convex hull. If any point of B is outside the convex hull of all the points, then it is no. Okay. For example, let's say this was B and let's say this was A. Okay. So the convex hull of all these points will be this, right? This will be the convex hull, and now we can see that the point of B, this point of B that lies on the convex hull, right? So my answer will be no, because now we can see that B does not strictly lie inside A. Okay, I hope this thing is clear to you. It's even here, it's also intuition. Okay, so let's code this question. Let's copy the input. This is the input. First I have n, that are the points of the polygon A. Okay, and then I have m, and then I have the m points of polygon B. Okay, so this much is fine. Now what I'll do is I'll take m and I'll run a for loop from 0 to m, right? And let's take a point called temp. Let's input this point, temp dot x, temp dot y. Okay, and let's put this point behind P, so that my P vector contains all the points, that is n plus m points. Okay, so okay, and now guys, in the end I need to check whether my point P will lie inside, whether a point from polygon B lies inside the convex hull or not. Then what I'll do is I'll just take let's hash those points of B. Okay, so pair intent map, and let's have hash these points, temp dot x comma temp dot y. Okay, so I've hashed all the points of B polygon. Now at this place my P contains all the points of the convex hull, right? All the points of the convex hull, and the convex hull is of all the points including A also and B also, right? So yeah, so I've got this output. Now I have all these points. Now I just have to check whether these points lie completely inside, whether any of these point is a point of B or not, right? If any of this point is a point of B, then my B will lie outside A. That's why it's coming in the convex hull, right? If mp dot count x dot x comma x dot y, then what I need to do is see out no. Okay, and I'll simply return. Otherwise I'll see out yes and I'll return. Okay, so we got yes here. Now let's try to submit this question on Codeforces. New.cpp. Yeah, new.cpp. Okay, so guys, the solution is accepted. I hope convex hull is clear to you. You can try other problems also. You can try the problem named erect the fence from LeetCode. Okay, that's a good problem. Erect the fence. Okay, and also you can search other convex hull problems and use the same code. Okay, thank you.
Hi everyone, so in this lecture I'm going to discuss a problem in which you have to check whether a array contains a subarray whose sum is 0 or not. Okay, so you need to check in a given array if there is a subarray whose sum is 0 or not. So let me give you one example of an array. For example, 6 minus 1 2 1 and -1. So does it contain a subarray with 0 sum? Obviously yes. You can see this is a subarray whose sum is 0. Okay, and there could be another array. If I have this, then also you can see this is a subarray whose sum is actually 0, and there is also one more array which is this subarray also has a sum that is equal to 0. So you need to print true or yes if there is a array like this, otherwise you need to print false. So let us see how we can solve this question. So the very first approach is a brute force approach. In the brute force approach, you will generate all subarrays. Okay, for all values of I and j, you will find out the sum of the array by doing an iteration. Okay, so I and j can be selected in NC2 ways, that is n square ways to select I and j into the time to compute the sum. So that is also linear. So that would be order of n cube. But we know we can do something better by making a prefix sum or a cumulative sum array. Okay, so what we can do, we can say, okay, instead of computing the sum of every array, we can store the prefix sum. Okay, so for the first element it is 6, when you add the next element it is 6 minus 1 5, then you add 2 it becomes 7, then you add -1 it becomes 6, then you add 2 it becomes 8, and then you add -1 it becomes 7. So this is the prefix sum array. Okay, so now again you can select all pairs of I and j in n square ways, but in order to compute the sum from, let's say, I plus 1 to j, if you want the sum of this part, you can simply say it is nothing but its cumulative sum of j, that is the total sum up to the jth position, minus the cumulative sum till the ith position. So this is what is the sum of a subarray. So it can be computed in constant time. So the overall complexity would be order of n square. But we just need to check whether there is a subarray or not. So what we want is this cumulative sum, this subarray sum should be equal to 0. So that means cumulative sum of j minus cumulative sum of I should be equal to 0. So that means C sum of j should be equal to C sum of I. Basically, we need to find out two indices where the cumulative sum stored is equal. So if you carefully check, at this index and at this index, the sum is equal. So basically, if you see between these indices, the last three elements, okay, I plus 1 to j, that means these last three elements, so they have a 0 sum. Also you see there is a 6 here and there is a 6 here. Between these indices also, if you say, okay, I pick this 6, I pick this 6, and if you subtract 6 out of this 6, you will get these three elements. Okay, so these three elements, so this sum is also 0. So what you can do is you just need to maintain in your prefix array whether there is a sum which is repeating or not. Okay, so you need to find out whether there is a number that is repeating or not. So in order to do that, you can either take a hash map, you can make a unordered map of the type int comma bool. Okay, so you start inserting 6 in the map, then you get 5, you said it is not there, you insert 7, it is not there, then you encounter a number 6. So as soon as you encounter a number 6, you can say, okay, this 6 is already present, so that would mean that you find out a subarray with a 0 sum. That's it. Or what you can do is, if you don't want to take an unordered map, you can also take an unordered set of the type integer. So in the set, we can directly use the find function to check whether this number was coming earlier or not. You can take a unordered set as well of the type. So let me quickly discuss the implementation. I would be using unordered set. You can use unordered map if you want. Okay, so let's see how we can solve this problem. So I have this function checksum that gets the array, that gets the number n, and here I am going to make a unordered set of the type int. Let's call it as s, and first I will compute the prefix sum. So int pre equals to 0, and then I'm going to I'm not going to build the prefix here. I'm just going to compute a running prefix sum, and I'm going to store that sum in my set I less than n I plus plus. I'm going to say okay, prefix plus equals to array of I. At the ith position, this is the prefix sum, and we are going to insert this prefix sum in the set. So I'm going to say s dot insert prefix sum. But before insertion, you can check if the sum was already present in the set. Okay, in that case, or it is also possible the prefix sum comes out to be 0. So if prefix sum is 0, for example, if you get an elements like let's say -2 1 1, so at this index you will say the total prefix sum is 0. So in that case, obviously this is a sub array where the prefix sum is 0, and you can return your answer. Okay, so if prefix sum is 0 or s dot find prefix is not equal to s dot end. Basically, find function returns an iterator to the end of the set if the number that you are finding is not present. Otherwise, it will return the location of that. Okay, iterator to that position where it is present. So that means uh, you call the find function and it returns something that was not equal to end. That means that number was present already in the set. So in that case, we will say return true. We found a sub array in which the sum is 0. Otherwise, you can say return false. That's it. And let's build our code and let's try to run it. Okay, let me give a sub array 6 minus 1 2 1 minus 1. So it says yes. If I change it to something else, 1 2 3 4 5, then it says no. So you can see we got the correct answer, and this is how simple the code is. So you can now see that we reduced our complexity from order of n cube to almost order of n. Okay, and if you use unordered map and you say okay, the complexity of finding the element is almost O1, so it would be order of n exactly in that case. Okay, so that's all for this video, guys. Thank you. Hi everyone, so we are going to discuss a problem in which we have to find out the length of the longest subarray with zero sum. Longest subarray with zero. So in the previous problem, we have already seen how we can find out the subarrays whose sum is 0. So now this problem is slightly little bit modification of the previous problem only. So let us say you're given an array like this: 0 minus 1 1 2 5 minus 5, and let's say this is the array you have. So you need to find out what is the largest subarray whose sum is 0. So let me mark the indices also. Okay, and let us also compute the cumulative sum as we have discussed. It is going to help us to optimize the problem. So it's going to be 0 minus 1 0 2 7 and 2. Okay, so now clearly you can see there are two subarrays whose sum is 0. Okay, there are more actually. This is one subarray, and this is another subarray, and this is another subarray. Okay, and this is another subarray. So basically I'm just checking the array between 2 and 2, the array between 0 and 0, and the array up to 0 is also a subarray whose sum is actually 0. So all the arrays up to 0, they have a 0 sum, and all the arrays between same digits, let's say between some number x and x. So this is open bracket, this is a close bracket. For example, between this 2 and 2, this 2, you see this part of the subarray is having a 0 sum. Between this 0 and between this 0, this part of the array has a 0 sum, and also the entire array up to this point is also having a 0 sum. The entire array up to this point is also having a 0 sum. So what we are going to do now, if we want to compute the difference between the indices, okay, so we already know how to find out the subarray between with 0 sum. So we need to find out either the numbers in the cumulative sum array where the total sum up to that point is 0. Okay, so in that case, let's say uh, up to second index this sum is 0, so we can say the length of the array is nothing but I plus 1. So that's going to be 3, where cumulative sum of I is equal to 0. So that's one case. So this is how you can compute the length. But between x and x, let's say x is having an index of I and this x is having an index of j. So in that case, length would be nothing but it would be like 5 minus 3. It would be j minus I. So it would be 5 minus 3, that is equal to 2. So this is how we can compute the length for the second case. Now let us dry run our code. We are going to find out, okay, we are going to take an unordered map because we need to store what was the sum, that is an integer, and at what index it occurred, okay, that is also an integer. Let's call this as m. So I'm going to store the cumulative sum and the index at which this particular sum occurred, okay. And if a sum is repeating again and again, we will store the first occurrence of that sum. We will store the first occurrence because we want the longest subarray. For example, if you have some element -2 here at this place, then at the 6th index this total sum is going to be 0. And if you want to find out the longest subarray, that would be nothing but the array starting from index 0 up to the index 6. That would be since this is 0, so we will use this logic. So largest subarray will have a length of 6 plus 1, that is going to be 7. Or I hope you're getting this idea, okay. So if a number is repeating and again, so if 0 is coming here, 0 is coming here, 0 is coming here, you will basically pick the first occurrence, okay. But for 0 we also have another criteria that we can actually check this thing, this length would be greater actually, okay. If you're doing some subtraction, length of j minus I something, or you're doing j plus 1, so obviously this value would be higher, okay. So if the number is 0, then we have another option that you consider all the elements till the jth point, okay. That's what I'm saying. So let us try to dry run our code. So I will first note that I'm getting a 0, so I will store 0 along with the index at which it occurred. So this index is going to be 0. So here we have sum, here we have index, and here we are computing the length. So since it is 0, so length will be computed by I plus 1, so it would be 1. Next we get is -1. So -1 occurred at the index 1. So -1 was not present in the hash map till now, so we will not do anything, we will just skip. Next we go to next index, we again get a 0, and 0 was coming earlier, okay. So what we can do is we can compute the length using this logic. Length is I plus 1, so that means I is 2, so sorry, I is 2, so the length is 3. So we can say our max length is now going to be 3, and we are not going to update the first index, first position of 0, because we need to store the first occurrence of every number. Next we go to 2. So 2 is not present in the hash map, we insert it, okay. So the maximum length till now is 3, and 2 is coming for the first time, we know the index of 2, that is 3. Next we get is a 5 is coming for the first time, we store the next is actually 7. So 7 is coming for the first time, we store the index as 4, we do not change the length. Next we get is 2, so 2 is already present in the hash map. So what we do, we see, okay, what is the largest sub array that can be formed by subtracting 2 from the previous 2. So current 2 has an index of 5, the previous 2 has an index of 3, so I will update my length as 5 minus 3, that is 2. That is smaller than the max length, so I do not update my max length. So max length still remains 3. Next I go to this number, that is 0. So at 0 I can say the maximum length would be I plus 1. So 0 is already present, but that does not matter because we can consider the entire array up to this index. So this array contains 7 elements, so the max length would be now 6 plus 1, that is 7. So we can update our max length variable to be 7. So finally this is what you are going to get. So I hope this logic is clear. Now we will dive into the implementation. Okay, so let's write some code here. So instead of taking unordered set, this time I will take unordered map because I want to store key value pairs. So here I will have unordered map of the type int comma int. Let's call this as m. Let's say prefix sum is 0. Let's say length is also 0. And for int I equals to 0, I less than n, I plus plus, prefix plus equals to array of I, and then I can check if the current element is 0. Okay, then I can say my length is going to be maximum of my length or I plus 1. So initially I can say length is 0, then I can update my length as length is maximum of length comma I plus 1. And I can also do if you're getting a number that is already present in the hash map. For that case I can say if m dot find pre not equal to m dot end. It means you're getting a number 2 and that 2 is already present in the hash map. In that case the length would be computed as the maximum of your length whatever you have and your current answer. So current index is I minus the first occurrence of prefix sum. So that would be map of prefix. Okay, that's it. And finally you can say return length. So build is successful. Let's try to run the code. So here I can say, okay, I missed out one case, right? Otherwise if the number is coming for the first time, then we need to say map of prefix, this is equal to I. So this would be for the case when a number is coming for the first time. So we are going to store the first occurrence. If the number is repeating, this case would be executed. If the number is 0, this case would be executed. So this is how we can actually build the code, and let's also call the function. The return type would be integer. So I can say cout longest sub array with 0 sum. We have array and we have n, and let's try to run the code now. So this is length of longest sub array. So I need to give inputs. So I have 7 elements. Let's say 0, minus 1, 1, 2, 5, minus 5, and minus 2. Okay, I gave a wrong input here. This thing, let me just correct it. 7 elements, 0, minus 1, 1, 2, 5, minus 5, and minus 2. Okay, sorry, one mistake I made. So this should be prefix of, this should be sorry, this, yeah, this should be prefix sum equal to 0. Okay, so you should make this change. And now let's run our code. Let's give 7 elements: 0, -1, 1, 2, 5, -5, -2. So you can see answer is 7. And if I give, let's say, 6 elements: 0, -1, -1, 2, 5, let's say 4 and 3. So in this case the answer should be 3. Yeah, the answer should be 4, because you can see these are the 4 elements. If you find the sum of this subarray, it's actually going to be 0. Let us try one more case. 7 elements, but first element is 1, 0, -1, -1, 2, 4 and 3. So in this case the answer is again 4. So that's how we can solve this problem. I hope you would be able to solve it now. Okay. Hi everyone. So in this video I'm going to discuss a very similar problem in which you have to find out the longest subarray whose sum is k inside a given array. Okay, so we have already solved a problem in which we have to find out longest subarray whose sum is 0. So you can see this problem is actually a special case of this problem where k is equal to 0. So what you need to do, suppose you're given an array of elements starting from a1, a2, a3 up to some a j, or let's say ai, and up to aj, up to an. So you need to find out a subarray, let's say from ai to aj, such that aj minus, sorry, sum of all sum of elements from uh, I to j, this is equal to k. Okay, and this array should be longest, so j minus I should be the largest possible difference that we can get. So we have already seen that first thing we need to do is to make a cumulative sum array. Let's say we make a cumulative sum array c1, c2, c3 up to cj, ci, cj and cn. So cj denotes the total sum up to this point, ci denotes the total sum up to this point. And what we need to do is we need to say, let me just say this is I plus 1, right? Okay, and we have c of I plus 1. So if you want the sum from the index I to j, you can simply I plus 1 to j. Okay, then you can subtract the sum cj minus ci. So this basically gives you the cumulative sum for the array starting from I plus 1 till the index j. This is what you actually get. So what we want is cj minus ci should be equal to k, and we want the largest subarray that satisfies this property. So we can also say that your ci is nothing but it is equal to cj minus k. Okay, okay, this is something that you're expecting. So again we can easily use the hash map. Okay, so for example, let's say the value of k is, let's say, 3 at some index. Let's say the cumulative sum is 6. So what you need is you need to find out some index I in this range where the cumulative sum is 6 minus 3. Okay, so if you get this particular sum, then you can clearly say that sum of this subarray would be equal to k, that is equal to 3. Okay, or if k is 2, then you need to find out some number, some cumulative sum whose value is 4. So that's going to be pretty easy if you are going to use a hash map. So in the hash map we are going to maintain uh, the sum and the index at which this particular sum occurred. So if you know, okay, the current sum is 6 and you need to find out the last sum where the value is 6 minus k. Okay, you need to find out the occurrence of 6 minus k. If it is present in the hash map, then you are good to go, and if it is not present, then there is no possible array at this particular index. there could be another case. Okay, so this is one case. Another case could be, let's say your current sum is equal to k. If you have a current sum and let's say this sum is equal to k, that's equal to 2, then clearly you can say, okay, I will take the entire sub array from the range 0 till the current index, whatever is the current index, and that will basically give me how many elements? Current index plus 1 elements. So if I say okay, the cumulative sum of all the elements from, let's say, 0 minus 1 1 1 1, okay, if you carefully see the cumulative sum till this point, this is going to be 2, and this index is 0 1 2 3 4, then you can say, okay, the subarray is having a length of 5. Okay, that's what we are going to do. So let me just explain you with the help of one example. So suppose your array is 1 minus 1 5 minus 2 and 3. So what you can actually do is 0 1 2 3 4, and here what you can say is, let me just make a cumulative sum array also. So this would be 1, this would be 0, this would be 5, this would be 3, and this would be 6. Okay, and let us say the value of k is 3. This is your array, this is your cumulative sum array, and let us try to go to each index and do the work side by side. So you go to the 0th index, you say, okay, the sum that you're getting is 1, so 1 is present at the 0th index, so this is the sum and this is the index. Okay, next you go to other index, so you get a sum of 0, so it's not present in the hash map. You say, okay, we are getting a sum that is equal to 0 and it is present at the first index. Okay, and at the same time we also need to check, we need to look for a possible sum. So 1 minus k, so we have to look for minus 2, so minus 2 is not present in the hash map. At 0 we need to look for minus 3. Okay, so basically we need to look for sum minus k, if it is present or not. So it's not present, it's not present in the hash map. Next we go to 5, so 5 is present at index 2, and we have to look for a sum of 5 minus 3, that is 2. So 2 is also not present in the hash map. Okay, next we get a sum that is equal to 3 and it is equal to k. So in that case we can simply say our length is going to be index of 3, that is equal to 3 plus 1. So that answer is going to be 3 plus 1 4. So this is going to be one possible answer. That means your sum up to this point is equal to 3. So this is a subarray whose sum is actually 3. This is the largest subarray, and you can verify 5 minus 2 is 3 and 1 minus 1 is 0. So 3 plus 0 is 3. So here you get one possible subarray, and then you go to next index. You can see the next is 6. So we need to look for, okay, let me store 6, and 6 is not coming in the hash map, so I will hash it. So 6 is coming at index of 4, and what is the value I need to look for such that difference of those two values should be equal to k? So that value should be 6 minus 3, that is 3, and 3 is also present in the array at an index of 3. So in this case the length would be current index, that is your 4, minus the index of previous occurrence of 3, that is also 3. So you get a length 1. Okay, so in this case you can see this, there is a subarray of length 1 and it contains an element 3, and this is what the sum should be. So we get another possible length. So finally what we need is maximum of the all lengths. So the maximum length is finally 4. So you can see the logic is almost same as the previous problem. So what we can do is we can just modify our code and we can do the work. So you can see here I'm just going to take the previous code and I'm going to modify it. Longest subarray whose sum is k. So I get the array, I create the hash map, I take a variable to store the prefix sum, and I say okay, the length is 0, so prefix is updated as you get the ith element. And here we can check if prefix is equal to instead of checking it is equal to 0, we can check if it is k, then your length is going to be maximum of your previous length and your current answer. So current answer would be I plus 1 as I discussed. And otherwise you check if the number is present in the hash map or not. If the previous number is present, then we need to actually check for this thing. Yeah, so another change that you need to make is you need to find out what is the previous occurrence. So the sum that you need to look for is pre minus k. Okay, so let me just repeat. If this at this particular index, if you're making a sum of 6 and your k is 2, so you need to look for an index up to which the sum is 4. So you will look for pre minus k. Okay, so that is going to be 4. So if this index is I and if this index is j or whatever it is, so you will basically get a subarray from I plus 1 to j that is equal to the that is having sum equal to k. So here it would be pre minus k, and here it would be again pre minus k. So from the hash map you will pick the index of the term where the sum is pre minus k, and you will update your maximum length as a maximum of your current maximum and your current answer. Okay, otherwise whatever sum you're getting, and that should be stored in the hash map, and we are storing the first occurrence inside the hash map. So I think that's it. And in the input you need to input n and k. Okay, we need to provide one more parameter here, int k, and build is successful. So let us try to run the code. So it's called as longest subarray with sum k. So let me give a subarray. So let's say we have 5 elements. The k should be 3, 1, minus 1, 5, minus 2, and 3. So you can see we are getting the answer 4, which is the correct answer for this array. And you can see if this is the subarray. Okay, so this subarray has having a sum of 3. Hi everyone, so the problem we are solving is longest consecutive subsequence. Okay, so it should be subsequence here. So what the problem says is, given an array, let's say you're given this array, you want to find out the longest consecutive array. Okay, so consecutive subsequence, that means a subset of elements of this array so that they are adjacent to each other. For example, if I pick 19 and 20 out of this array, okay, so they form a subsequence. If I pick a 10 out of this array, they also form a subsequence. 10 and 4 is also a subsequence, but it is not a consecutive subsequence because 4 is not followed by 10, so we ignore this. And another subsequence you can find out is 4, 1, 3, and 2. So if you just say 4, 1, 3, and 2, then all the elements of this subsequence are adjacent to each other, because if you just sort it, it becomes 1, 2, 3, 4. So we can say this subsequence is made up of consecutive elements. So in our case, the largest length that we can make is 4. Here the length is 1. Here the length is 2. So out of this, the longest one is this one. So for this array, the output would be 4. Now let us think how we can solve this problem. So there are multiple ways to solve this. So in the first video I will discuss about two basic ways. So one way is you sort this entire array. You will get as 1, 2, 3, 3, 4, 10, 19, and 20. Okay, you can do the sorting in n log n time, and you will end up getting this array. And in this array you can actually start iterating from the first index. and you can see, okay, is the next element adjacent to the previous one? Yes. So you expand your window. Okay, is the next element same or one larger than the previous one? So you expand your window. So you will expand your window until this point, and you will count the unique elements. So unique elements would be nothing but you will have 4 unique elements. But as soon as you reach 10, you will start a new window. Okay, and this window will be over at this particular index. So you will get one element here, and next time you start from 19 and you will get 2 elements in the window. Okay, so we are combining the consecutive elements in the same window, and this is how we can take the maximum of all of them, and you will get 4. This is one way. Another way could be you can iterate from the minimum to the maximum element. For example, you can do something like this: for int I equals to min till the max element. Okay, and you can store all the elements in the hash map. So there is a hash map that tells you, okay, whether this element is present in the hash map or not. So what you do, you try to get the count of each element. If let's say map.get I, if this count is greater than 0 or not equal to 0, then you can say count plus plus. That means you basically got one element. Okay, so in this case we will be iterating over only unique elements. For example, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, so you can see in this range we do have the groups, like this is one group, this is another group, and this is another group. All other elements are not present in the range. Okay, so we just iterate over this particular range from 1 to 20, and we check if 1 is present, we say okay, count plus plus. 2 is present, count plus plus. 3 is present, count plus plus. 4 is present, count plus plus. 5 is not present, then we will enter the else case. Else what we can do, so that means we found out one group that was present. So in that case we can say, okay, our answer is going to be maximum of our current answer. Let's say initially the answer is 0, and whatever is the count we got, so count we got is 4. And for the next group that is going to start from, let's say 5, we will say the count is going to be 0. So at 5 we don't get anything, count remains 0. At 6 we don't get anything because this is not true, so answer would be maximum of previous answer, that is 4, and count is 0. At 7 nothing happens, 8 nothing happens, 9 nothing happens. As soon as we reach 10, so 10 is present, so count becomes 1. At 11 is not present, so we enter the else block and we say, okay, answer is maximum of previous answer, that is 4, and current count, that is 1. So we end up getting 4 as the answer, and so on. Okay, and finally we will compare 4 and 2 here, and final answer will remain 4. So the complexity of this approach would be O of max minus O of min, and if the difference between max and min is too large, for example if min is 1 and max is, let's say, 10 lakh, then you will end up spending more time than order of n in this problem. Okay, so although it looks linear, but it can take a lot of time if the difference between max and min is quite large. In the next video we will discuss some more optimizations that we can do. Hi everyone, so in this video we'll be discussing a solution to the problem largest consecutive sequence, and we have discussed one sorting based solution. Now I will discuss another solution that is based upon hashing. Okay, so it's an efficient solution, but it's a bit tricky to implement, and in the next video I will discuss an easier solution based upon set data structure that we will see in the next video. But let us see how we can solve this problem efficiently using hashing. Okay, so let us see, let's say you're given some numbers. Let's say the numbers are 14 5 1 2 6 3 7 8 9, and let's say 13 and 15. So if you carefully observe, you can find some streaks in them, right? So a streak is a range of consecutive numbers. For example, 1 2 3 So 1 2 3 is a streak, right? Similarly, you have let's say 4 is not there, 5 6 7 8 9 is a streak, so that is another streak. 5 6 7 8 9. And similarly 13 14 15 is another streak, so 13 14 15. If I talk about what is the largest streak, this is the largest streak, okay? But question is, how do we find it? So let us say we already know the streaks present in this particular part of the array. And how do you represent the streak? We represent each streak by its start index or start value or the end value, okay? For this streak, the start is 1, end is 3. For this streak, the start is 5, the end is 9. And if you know the start and end, you can generate all the other elements of the streak, okay? But for the streak, the start is 13 and the end is 15. Now suppose you get a new element. Let's say you get an element 12. So what can happen? So if you know that now 12 can do one thing, what we can do with 12 can get attached to this particular streak, okay? So 12 can get attached here, and it can help you to expand the streak to the left. That is one option, okay? So when you have when you get a new element, when you insert a new element in the array, or when you consider a new element, it can help you to expand the existing streak, okay? So you can expand the streak towards left, so it can help in left expansion of a streak, okay? That is one possibility that we can have. Suppose we get a number 20, so number 20 is not present. So for number 20 we don't have uh, 19 or we don't have 21 in the array. So what we will do, we will say okay, 20 will start its own streak. So we will have a streak of length 1 that is starting from 20. So you can start a new streak of length 1. That is another option, okay? What else you can do? Let us say you get a number 10, okay? So in that case, the number can get attached to the right of some element, okay? Or it can come let's say before some element, okay? So if 11 was present, then the 10 could come before 11, and if 9 was also present, then 10 would come after 9. So another option could be, it can help in right expansion of a streak. So you expand the streak size by 1, but towards right, okay? So from 9 you go to 10, so 10 becomes the new endpoint of the streak. So that is another possibility. Another possibility is, suppose you get a number 4, okay? So what will happen if you get a number 4? So that number will basically go here, okay? And if you carefully look at this, it can concatenate two streaks. So your effectively streak size will increase. So it can join the left and the right streak, okay? So that is one thing it can do. So that will actually help us to increase the streak size, because 4 is coming after the ending of a streak, and it is also coming before the starting of another streak. So how do you know that 4 will come after 3, and how do you know that 4 can come before 5? So what we will do, once we get a number 4, so we will maintain a hash map for every number that we have inserted in the array, okay? So if we know that 3 was present in the array, okay, so we will look for 3. We will say okay, 3 is present, and we will look for how big is the streak length ending at 3. So how big is the streak length ending at 3? So in the hash map, what we will store, we will say okay, we have the number 3, and the length of the streak that is ending at 3, or in which 3 is a part, this length is 3. So this is how you will get reach the starting point of this particular streak, okay? Now when you get 4, you will also look at if there is a number that is just 1 greater than 4. Again, look into your hash map. So let us say when we inserted 5, so 5 was present in the array, and 5 will store, this is going to be the key and this is going to be the value. So what is the length of the streak that in which 5 is a part of? So 5 is a part of a streak that starts from 5 and goes till 10. So you have 6 elements. So you have 6 elements in that particular streak. Okay, so you come to know, okay, 5 is also present and it contains 6 elements in this particular range. Okay, so what do you do when you concatenate two streaks? You can simply say, okay, the length of the new streak will be nothing but length of the old streak, that is L1, length of the left streak, that is L1, length of the right streak, that is L2, plus 1, because you're adding a number. So in this case, if you insert a 4, the effective streak length would become how much? It would become 3 plus 6 plus 1, so it will become 10, right? So 3 from left, 1 from the middle, and 6 from the right. So it will become 10. Now you may ask, where do we update this length? Okay, kahan pe update karna hai? So what do you need to do? So one idea is you update. Now this, this whole thing is an entire big streak, right? And all the numbers in the streak are continuous, right? So one way would be you update the streak length for all the elements present in the streak, right? But that is going to be something very inefficient, right? The only important elements of a streak are the first element and the last element. Okay, so first element is 1, the last element is 10. So what do? You just update the streak length for these elements. So you say, okay, 1 is a part of a streak which contains 10 elements, and 10 is a part of the streak which contains 10 elements. Okay, so this is how you update the streak length for 1 and 10. So in the hash map corresponding to the entry 1, you update, let's say the old value was 3, now you say, okay, it's going to be 10. And similarly for 10, the old value was something like, let's say 6, now the new value is 10. Okay, so that is going to take order one time, right? So I know it's a bit difficult to understand in the first go, but let us try to dry run it with the help of one more example. But I hope you guys got an idea. If you know the element is going to help in left expansion, and you know the length of the streak in which this element is getting added is L, so the effective streak length for the new streak would be L plus 1. Similarly for the right expansion, it would be L plus 1, like this. And if you insert a new element, okay, then yeah, for the right expansion it would be L plus 1. And if it does not, if the map does not contain the smaller element and the bigger element than the current element, then obviously you start a new streak of length 1. You say, okay, let's insert 20 in the map, and 20 is going to have a length 1, right? So let me dry run it with a better example so that you guys are able to understand it in a better manner, right? So let us say the elements are 14, 5, 1, 2, 6, 7, 8, and 9. So let me just take these many elements. So now you get the element 14. What do? Your hash map is empty, right? So your hash map is empty as of now. You say, okay, 14 is going to form a new streak of length 1. So you say, okay, 14 is going to have a length 1. Then you get 5. So you check for 4 and 6 are not present in hash map, so 5 is going to form a streak of length 1. Then you get 1. So 2 and 0 are not present, so you say 1 is going to form a streak of length 1. Then you get element 2. So now 2, you look for the values 1 and you look for the value 3 also. So 1 is present, 3 is not present. So 2 will help to in the right expansion of this particular streak 1. So what do? You say, okay, I'm going to add 2, but 2 minus 1, 1 is also present, and that has a streak of length 1. So I say, okay, what I do, 1 was already present. So what we will do, we will say, okay, 2 is going to get added, and the new streak length for 2 is going to be 2. And also we will update the streak length for 1 because 1 is a part of the streak that contains 2 elements. So again, you can see we got did 2 updates, start and end. Okay, so that's how we get this length. Now you get an element 6. So 6 can be concatenated with 5. Okay, so you check 6 minus 1, 5 is present, 7 is not present. So what do? You add 6 here and you say, okay, 6 minus 1 is 5, the old streak length is 1, so it is going to be 1 plus 1, that is 2, and you also update this length as 2, right? Then you get 7. So what do? You say, okay, this is 2, this is 2, and you are going to add 7. So now you see, okay, 7 I can add, 7 is going to get added. So 7 minus 1, 6 is present, 8 is not present, so it is going to help in right expansion. So what is the streak length ending at 6? So this length is 2. So if you add a 7 here, the effective streak length would become 3, and in this case, we will not update the streak length of 6 because we are only worried about the start and the end element. So what we will do, we will say, okay, what was the streak length that was given by 6, that is element 1 less than 7. So what we will do, we will go to an element that is current number 7 minus old streak length, that is 2. So we end up getting at 5. So we reach this value 5 and we say, okay, the new streak length is now 3. So we say, okay, 5 has a streak length 3 and 7 has a streak length 3. That's what we do. Now we get an element 8 and we say, okay, 7 is present. So what we do, we make this length as 4 and we do 8 minus 3, that is 5, and we also make this length as 4 and we also update this length as 4. Okay, so I'm not updating these because they are useless. Okay, so only the elements that are at the beginning or at the last, they are helpful. So that's why we are just updating it. Okay, now you may ask why 5 is helpful. So suppose somehow you get the elements 3 and 4, then 4 should know what is the streak length of the number that is starting from 5. So that length should be 4, right? Now you get an element 8 and then now you get an element 9. So what do? You add a 9 here. 9 will have a streak length of 5 and also you will update streak length of this as 5. So it also becomes 5. Okay, now let us add some more elements. Let's say you add 4 here. So what will happen? 4 is not present, but 3 is also not present, right? So 4 will ask for 3 and 5, but 5 is present, 3 is not present. So what happens is you can add a 4 here. Okay, and you can say, okay, what is the streak length starting from 5? It is 5. So streak length starting from 4, it would be 6. And also you need to go to the last element of this particular streak, that is 9. Okay, so how do you go to it? You say, okay, 4 plus the old streak length, that was 5, so that gives you 9, and you reach 9 and you say, okay, streak length of 9 is also 6 and streak length of 4 is also. So this is how you keep on updating. And suppose you now get an element 3, so that joins these two. So what happens in this case? So 3 now knows I have 2 in the hash map, I also have 4 in the hash map. Streak length of 2 is 2. Okay, so you basically go to 3 minus 2, you go to the index 1, and also streak length of 4, that is 6. So you go to 3 plus 6, that is 9. 3 plus 6, that is 9. And at these indices you also update the streak length. So what would be the new streak length? It would be 1 plus left streak length, that is 2, right streak length, that is 6. So that is 6 plus 2 plus 1, that is 9. Okay, so you say, okay, go to this index, you update this streak length as 9, and you go to this index, you update this streak length as 9. So now 9 will have 9 here and 1 will also have 9 here. Okay, and that's how we basically do the update. Okay, and 3 will also have 9 here, right? So I hope this logic is clear, and what we will do now is we will do the implementation of the same approach. Okay guys, so let's write the code for the problem. So what I'm going to do, I'm going to complete this function, and the approach that I've discussed, that will require a use of unordered map. So I say, okay, I will make a map between int and int, and let's so the mapping is between the number or the value to the streak length. Okay, value is the streak length. So what we do, we iterate over all the elements of the array, and we try to insert every element in the hash map, and correspondingly we update its streak length. So this is the current number is a of I, and we can check if m dot count of number -1. So that means if the number is 4, then we look for 3 and we look for 5. If both of these numbers are not present, so that is the simplest possible case. So that means we are starting a new streak, so its length would be 1. Otherwise what can happen is we can have both, right? So that is another extreme case. So let's say we are current number is 4, and in our hash map 3 is also present and 5 is also present. So then in that case we need to join the two streaks, right? So what we do, we check the left streak length, that is m of number minus 1. We check the right streak length, that is m of number plus 1. And we say okay, total streak length would be nothing but the left length plus 1 plus the right length. Okay, so that is len2. And we update the streak length at m of number minus l1, that is going to equal to streak, and m of number plus l2, len2, that is going to be equal to streak. So we are basically updating the starting and the ending points of the streak with the new streak length. Okay, so that is what I have discussed. Similarly, we can have a case in which the left part is present and the right part is not present. So not of m dot count of n plus number plus 1. In that case, we say okay, what is the streak length of the previous part? So let's say like 1 2 3 is present, and you then 7 8 9 is present, and you get a number 4. So now 4 will look for the value 3. 3 is present but 5 is not present. So in that case you will say okay, what is the streak length of this particular part? That will be given by m of number minus 1, because at the end of every streak that we have formed so far, we know what is the streak length. So that is given by this particular hash map. So what we do, we say okay, m of number minus len equals to len plus 1, and m of number equals to len plus 1. We say okay, add 4 here and update the streak length of 1 as 3 plus 1, that is old length 3 plus 1 4, and update the streak length of m of number, that is 4. So in the hash map you create this entry 4 corresponds to a streak length of 4, because a new streak is ending at this particular point. So that's what we basically do at this particular else if block. Otherwise we have a reverse case. We say okay, we do have the right part, we don't have the left part. So we say okay, m of number plus len equals to len plus 1, and m of number, that is equal to len. So that's what we do here, right? So let me just tell you what I've did. So suppose 5 6 7, and then you have 10 11 12. So suppose you get the number 8. So what do? You attach 8 here, and you say okay, m of sorry, you get a number 9, right? So what we do in this case is, we got 10 but we didn't get 8. So we say okay, length is m of number plus 1. So hash map of 10 will store the value 3. So we say okay, the new streak length is 3 plus 1, that is 4, and we say okay, m of number plus len equals to 4. So we update the value of index value of the key 12 as 4, and we put a 9 here, and we say okay, the streak length of 9 is also 4. So m of number equals to len, right? Oh, this should be also len plus 1, right? So that's it, right? So yeah, that's fine, right? So what we do now, we iterate over the hash map, and we try to find out the largest value. So let's say int largest equals to 0 for auto sum pair that is there in hash map, and we say okay, largest equals to max of largest so far and p dot second. So we are iterating over the values in the hash map, and from here we can return the largest. That's it. And let's build the code. Right, so this should be error of I. Build is finished, and the code is largest consecutive sequence. So it says the answer is 5 for this given array. So let us try to verify. We have I think lot of streaks here, right? Okay, so let's see. So we have 14 5. So we have 14 5 1 2, then we have 6, then we have 3, then we have 7 8 9, then we have 13 15, 11 12, and we have 17, right? So you can see the largest streak length in this case is going to be 5, and that is what we are going to get here. Let's say, so yeah, we get 5. But now suppose if I insert one element here, that is, let's say 10. 10 is going to join these two streaks, right? So streak length should become 5 plus 1 plus 1. The answer should be 11. So that should be the largest streak here, right? So what I do, I insert a 10 and I build my code, and let's run it. So you can see the largest streak length is 11. So this is how we solve this particular problem. Hi everyone, so now we are going to discuss another approach to the problem, largest consecutive sequence, right? So this is the array that was given to us, and if I just draw the streaks that we found out, so let me just draw the streaks that we have. We have a streak of 1 2 3, we have 5 6 7 8 9, okay, and we have 11 12 13 14 and 15. So that is something that we can make out of this particular array. So suppose you, what do, you suppose you know these numbers are present in the array, right? So what you can do, you can put these numbers in a hash map, or you can put these numbers in a unordered set, right? So why I'm using unordered set, I will tell you. So unordered set will basically tell me whether a number is present in the array or not. So that is something, it's going to be very useful, right? So I will create an unordered set and I will put all these numbers in the unordered set, right? So then what I will do, I will pick a number, I pick a number 14, and I see, do I have a number that is just 1 less than 14? So unordered set will tell me yes, there is a number 13. So I just skip it, I don't do anything. Then I move to the next particular element, that is 5. Okay, so I will ask, do I have a number that is just 1 less than 5? Obviously in all of these numbers I don't have the number 4. So what I do, I come to know that 5 is a number that could be a head of a streak, or the start of a streak. Okay, so I come to know that 5 can be a starting point of a streak, starting point of a streak. Then what I can do, okay, so then what I can do, I can simply do a traversal, right? So I can simply do a traversal, because what could be a number that is 1 less than 5? That is 4. If 4 is not present, then 5 is a point from where a streak is going to start. So if I know, okay, 5 is a point from where a streak can start, then what is the next number I have to look for? The next number should be 6. Is it present in the array? Yes, it is present. That I will come to know from the unordered set. What should be the next number after 6? 7. Is it present in the array? Yes. So I go to 7. What should be the next number? 8. So is it present in the array? Yes. What should be the next number? 9. Is it present in the unordered set? Yes. What should be the next number? 10. Is it present in the unordered set? The answer is no. So I found out all the elements of one streak, and I say, okay, the maximum streak that I found so far has a length 5. Then what I do, I go to a number 1. So do I have a number 0 that is 1 less than 1? So answer is no. So 1 can be a starting point of a streak. Okay, so streak starts here, and we do not know the length of the streak that starts at 1. So what I do, I look for the next number, I look for 2. So is 2 present? The answer is yes. So is 3 present? The answer is yes. Is 4 present? The answer is no. So what I have, I get another streak whose length is 3. Okay, so we have seen all these elements through the unordered map. Then I go to 2. I say, okay, do I have a parent of 2? Right, so do I have a parent of 2 that is present in the unordered set? The answer is yes. So we do not do anything here, right? Sorry, yeah, so we do not do anything at the number 14. We do not do anything at the number 2. So we go to 6. Do we have a number that is 1 less than 6? That is 5. Yes, we don't do anything here. Do we have a number that is 1 less than 3? Yes, 2 is present. We skip it. Similarly, we skip 7, we skip 8, we skip 9, we come to a number 13. So do we have a number that is 1 less than 13? 12. It is present, so we skip this. We skip 15. Do we have a number that is 1 less than 11? The answer is no. So what we do, we try to start a streak from a number 11. So we say, okay, 11 is the starting point of a streak. We look for 12, 12 is there. We look for 13, 13 is there. We look for 14, 14 is also there. We look for 15, 15 is also there. So we get all the elements of this particular streak. So you can say that we are doing some work, we are doing some iteration for all the elements that are starting point of the streak, and for all other elements we are just skipping them. We are not doing anything if we have a number that is 1 less than the current element. Okay, now this is a very elegant solution. I hope this you guys are getting it, and things will be more clear once we write a code. Okay, so those who have done graph theory, they can treat it like a DFS. Okay, so we are just traversing we are traversing different linear chains that we can form in this array, and in the worst case we are just going through every element twice, once when we are generating this streak and once when this element is a part of this array. So the overall complexity of this approach would be order of n, and the space complexity would be order of n as well, because we are using an unordered set that basically helps us to tell whether a element is present in the unordered set or not. Right, now let me jump into the coding part, and that will make the things bit more clear. So let us write the code using an unordered set based approach. So what I do, I take unordered set here. So the header file is unordered set. So I take a unordered set here, and it's going to contain integers. Okay, and let's say set. So let us iterate over all the elements in the array. For int I equals to 0, I less than n, I plus plus, I do s dot insert array of I. We have done an insertion. So insertion in unordered set also takes O1 time. That's a O1 operation on an average. And then what we do, then we will iterate over all the elements. Okay, so iterate over all elements and target those elements from which a streak can start. Okay, so what we do, for int I equals to 0, I less than n, I plus plus, again we are iterating over the array. Okay, so current element is what? So the current element is array of I. So we can say, let me just make it as a of. So I can what I can do, I can say, okay, if s dot find a of I minus 1, if let's say the current number is 5 and we say, okay, the 4 is not present. So if we try to find a number that is 1 less than the current element, okay, if this is not equal to s dot end, that means we let's say if this is equal to s dot end, right, that means we are not able to find a number, right? We are not able to find a number that is 1 less than the current element. So AI is a starting point of a streak. That's what it means. Okay, so what we do, we traverse the entire range that is contained in that streak. That's what we actually do here. So what you can see here is, so I can say, okay, then my starting point is nothing but AI plus 1, and I can say while s dot find, let me just call it as number, the next number, right? Next number should be AI plus 1, while s dot find next number is not equal to s dot end. So keep on finding the next number till you can find it. Okay, so what you can do, you can increase the next number plus equals to 1, and you also increase the streak count. Okay, so how many numbers are contained in the current streak? So streak length is 1, and you also keep on incrementing the streak length. So streak length plus equals to 1. Okay, that's how we do it. And once this while loop is finished, that means that entire range is covered, and you can say, okay, whatever is your max streak, that is max of streak length and max streak, and in the beginning you can just initialize max streak as 1, right, or 0, whatever you want to do. That's it. And once you're out of this for loop, you can return max streak, right? Okay, build is successful. So let us do one thing. Let's try to run this code. So this is using set, right? Yeah. Yeah, you can see the answer is 5, and that means the code is working fine. And let me include 10 in the streak, and the answer should be 11 now, right? So the answer is 11. You can see how simple the code is, and this code is again an order of n solution, right? Because uh, the total number of times this while loop is running is order n, right? So the total work this while loop is doing across all the iterations of this array, right, across all the iterations in this for loop is order of n, right? So the way it's working is like something like this. Okay, so you uh, found out one element that is a head of the streak, so it goes like this, it covers these elements. Then you found out some other head of the streak, it covers it like this. Then you found out some other head, then it covers it like this, then it covers it like this, and it covers it like this. Okay, so the total work done by this while loop across all the iterations of the for loop is order of, and that's what it has done here. And you can see how easy the code is and how easy the logic is. Just it was bit tricky to think for the first time, but once you have gone through this kind of a trick, you can apply it in future, right? So uh, if you want, I can just dry run it bit to explain it further if you didn't get the logic, right? So let's see with one example how the code is running. So maybe let's say we have elements like 4 5 3 1 2, and let's say 7 and 8, right? So what you do, you just put these elements in a unordered map, unordered set, and we have these elements 1 2 3 4 5 7 8, right? So these elements would be randomly ordered because we are using an unordered set, but I've just written them in one sorted order, but that could be in any random order. So what you do, you pick this element 4, you say okay, do we have a number that is 1 less than 4? Yes. So we have ai minus 1 3. So do we have this number in set? So that is not equal to s dot end, so we skip this entire code, we go to the next number 5. Do we have a number that is 1 less than 5? Yes, we skip this, we come to 3. Do we have a number that is 2? So yes, we have this number in the set, we skip this, we come to 1. So do we have a number 0? No, we don't have. So we enter this if condition, and we say okay, next number is 2, streak length is 1. Okay, streak length is 1, and next number is 2. While you are able to find the next number, so 2 is present. Okay, so what do, you say okay, streak length is now 2, you find the next number that is 3, streak length is 3, you find the next number that is 4, that is also there, so that number is also there. So you find the next number 5, 5 is also there. Okay, so you get a streak length of 5. Look for 6. Do we have 6? No, we don't have 6. So we update the max streak as max of 1 and 5, so we get this length as 5. Now we go to this number 2. Do we have a number 1 less than 2? Yes, we have, so we skip it. We go to 7. Do we have a number 6? No, we don't have. We enter this condition, and again we try to find the streak. Okay, so we get this streak 7 and 8. We go to 8. We have number less than 8, so we skip it. And finally we have this streak length maximum as 5. Okay, so this gives us streak length of 2, but the max remains 5. So that was a quick overview of this particular code, and that's all for this video, guys. Hi everyone, so in this video we would be discussing a very interesting problem, and the problem is you need to find the smallest window in a string that contains all the characters of a given string. Okay, for example, this is the input string that is given to you. Okay, so something like hello world, and there is a pattern EELO that you need to find out in this particular string. Okay, so you need to tell the smallest window size. So window basically means a substring that contains all the characters. Okay, so not necessary in the same order. So quickly think about this problem, how you can solve it, and then we will discuss the solution. Okay, so let's discuss what you can do. So one method is the brute force approach. Okay, so in the brute force approach you find out all the strings, all the substrings. Maybe you say, okay, let's say this is a substring, this is another substring, and then you check if the if all the characters of this string are present in this substring. Then you find out, okay, this is a valid substring, and then you find out out of all the valid substrings which is going to be the smallest one. Okay, so finding all the substrings is going to take n square time, and let us say if you use if you look try to match the frequency of each and every character, and let's say the worst case length of this string is also n, then it is also going to take order of n cube time. Okay, so that is the worst thing that you can do in this problem. But we know, we have studied so many concepts, we have studied so many algorithms, so we can do, obviously we can do something better. So can you think something better? Okay, the idea is, as the question says, what you need to find the smallest window. Okay, so wherever you see this term window, probably you can use some kind of a sliding window in this problem. Okay, so this gives us an idea of using sliding window. And uh, where you need to check, you need to find out uh, whether this window contains this particular string or not. So you can also use the concept of hashing. So maybe I'm going to use sliding window plus hashing as well. So where I'm going to use hashing, suppose I pick a smaller window. Okay, let us say I have this particular window, and this window contains how many characters? It contains 6 characters. So frequency of L is 3, frequency of O is 1, and frequency of E is 2. Okay, and in this given window, how many uh, characters I need? I need frequency of E as 2, which is present in this window. I need frequency of L as 1. So in the in this bigger window, the frequency of L is greater than 1. Okay, greater than or equal to 1. That means this window definitely satisfies our requirements. Okay, and frequency of O is also 1, and the frequency of O that we need in this pattern is also 1. Okay, so we need 2 A's, 1 O and 1 L. That is satisfied by this window, so it means it is a valid window, but it is not the smallest one. Okay, what would be a smallest window? So the smallest window would be this. If you just pick this LOEE, so this window is going to be the smallest window. So you can see L is 1 here, O is 1 here, E is 2 here, and this is what exactly we need. Okay, so even if you have a character, let's say A here, okay, in that case you can take this as the this as your smallest window. Okay, so this would be your smallest window. So we do have some extra characters in this window that we cannot skip, because you need to satisfy the smallest substring that contains all the strings given in the pattern. So in this case, this would be your answer, the window starting from L and window ending at E. Even this is also a valid window, but it is not the smallest one. Okay, so I hope you're getting what I'm trying to say. So let's see how we can approach this problem using hashing. Okay, so let us write down the steps. The very first step would be, you can initially make a check if the length of this pattern. Okay, so let's say this length is L1, or let's say this length is PL pattern length, and let's say this length is string length, this is SL. So if pattern length is greater than string length, then you can simply say return false. Okay, a direct check. Such a window is not possible. Okay, that is a corner case you can handle in the beginning. So handle the case, or handle the corner case in the beginning when uh, when your pattern is greater than string length. Okay, so something like that. In that case, no such window will exist. But otherwise, what you can do, you start from the left. Okay, you start from the left, and you make a frequency map of uh, all the characters of this particular string. Okay, so of your pattern, what you do, you make a frequency map. So you keep a frequency array, so let's call it as pattern frequency, or let me just call it as pf. So it says, okay, the frequency of E is 2, the frequency of L is 1, and the frequency of O is 1. So that is what is required. Okay, and this pattern frequency will be fixed because we are not going to change the pattern. But what we are going to change, we are going to change the size of the window, and we are going to change the location of the window. So we are going to run sliding window algorithm on the given string. So this is your next step. You make a pattern frequency array, okay, and initialize it with the frequencies of characters present in the pattern. Okay, that would be your next step. Third step is going to be interesting, and from here we are going to start with the actual sliding window algorithm. Okay, so what do, you pick the first character, you say, okay, I have h, okay, I have h till now, and I say, okay, I'm going to make another map, and let me just call it as something like string frequency. Okay, this is going to be another map, and I'm going to say, okay, h is going to have a frequency 1. Okay, but now I can check, does my pattern lie in this window? Obviously not, because I have a frequency of h that is 1, and I don't have these characters present in my window till now. So what I do, I expand my window. I also consider E. Okay, so we have window till E now, and I say, okay, frequency of E is going to be 1. So does the pattern fit in the window? No. So I expand it by one more step. I say, okay, let's include L. Does the pattern fit? No. I expand it by one more step. Frequency of L becomes 2. I check, does the pattern fit? No. I take the next L. The frequency of L now becomes 3. I see if the pattern fits. The answer is no. I go to A. I say, okay, I got one more character. The frequency of A is 1. And I go to O. The frequency of O is 1. I check, does the pattern fit in my sliding window? Obviously not. I go to E. Okay, so I put E inside my map here. Okay, E is already present, so I increment the frequency of E by 2. So does the pattern fit? Does the pattern fit at this point inside this? What we need frequency of E as 2, frequency of L as 1 or greater than 1, that both are fine, and frequency of O as 1. So the pattern does fit inside my window. So if you carefully look at this particular window till this point, so this is a valid window. This is a valid window. So we got one window, that is HELLLAOEE. This is a valid window, and we note the size of this particular window. Okay, we note the start index, we note the end index. So start is basically 0, and this is 0 1 2 3 4 5 6 7, and your current index I is going to be 7. So this is one thing you have to do, but you need to find the smallest window. Okay, so this is not the smallest window. So what we can do is we can start contracting our window. Okay, so once you find a large window, try to contract the window from the left. Okay, so the right side will be used for expansion, okay, and the left side would be used for contraction. Okay, so I will keep a variable start, and I will take this start to the next index if by excluding the value of h, my property that the pattern fits inside the window does not change. Okay, so if I just go to the next step, I will remove the h from my, I will reduce the frequency of h to 0, and I will still see, does the pattern fit inside my window or not. Okay, now you can see the pattern still does fit. So we got another sliding window, another output, that is ELLAOE. This is also a valid string, but it is not the smallest. Let us try to shrink it further. So next what I will do, I will remove E from here. Okay, so what happens is, as soon as I remove E, So the frequency of E becomes 1, and I see the pattern does not fit. Okay, so if the pattern does not fit, then I need to do expansion. So let us expand one more step here. So what it will do, it will take E here. Okay, so the frequency of E will again become 2, and you can see the pattern does fit inside our window. So what is your current what is the next window you get? You get L L L A O E E. So you can see this window does contain the pattern EELO. Okay, sorry, this is AOE. AOE. AO. Yeah, it contains two E's, one O, and one L. So what do? You find out a window which contains the given pattern. So what your goal is now to make it smaller. So we can make it smaller by shrinking from the left. So you remove this L, you go to the next index. You see, by removing this L, your output does you get a new window. Okay, LLAOE, because this string also contains all the characters of this given string. Okay, so you remove this L, you get another output, and this time the output you will get would be LAOE. Okay, so you will keep on repeating this for the entire string, and maybe once you have removed this L, then you will keep on expanding to include the next L. Okay, so you will get AOEE, include the next O, include the next space, include the next W, include the next O, include the next R, include the next L, and this would be another output you would be getting. Okay, so you can see here that it contains A, it contains two occurrences of E, it contains one occurrence of O, A is not required, and it contains one occurrence of L. Okay, this would be another window that you would be getting in the output, and out of all the windows that you have scanned, this one would be the smallest one. Okay, this one would be the smallest one. So I hope you got an idea how to build the algorithm. Now I will just write down the steps. Okay, so uh, or we will implement the steps in the uh, code video that we are going to do. Okay, so the whole idea is you will expand towards right to get the window, and once you get the window, you contract from the left to avoid unnecessary characters. Okay, or unrequired characters. Okay, so unrequired character would mean either the character is not present in the pattern, that is an unrequired character, or its frequency in the string is higher than what is required. Okay, is higher than what is required. Okay, and every time you get a window, every time you get a window, you update your minimum window by doing a comparison between the current window and the previous window you have got. Okay, or the minimum window you have got till now, by doing a comparison between current window and the minimum window you got till now, and finally you will output the minimum window. Okay, so these are the steps that we are going to do, and let's see the code in the next video. Hi everyone, so now let's discuss the solution to this problem. Find the smallest window that contains all the characters of a given pattern. Okay, so I have discussed the sliding window based algorithm. So in this video I will implement the same algorithm. Okay, so it is going to return the smallest string or substring that satisfies the given constraints. Okay, so we get the string S, we get the string pattern. Okay, okay, and let's compute the length of the string SL. So it's SL dot S dot length, and let's find the length of pattern PL, pattern dot length. Okay, and in the first step I'm going to check for the corner case. If pattern is greater than the string, then no such window exists. I can say okay, return none. No such window exists. Okay, and otherwise I'm going to make two frequency maps, or you can say frequency arrays. So one is going to be frequency for the string, how many, which character is coming how many times. We will need these to do a comparison. Okay, and another map for the pattern, frequency of pattern, and both of them are going to be initialized with 0. And then I said we will first count the frequency of pattern. Okay, how we will construct the frequency map for the pattern. So everything is 0, frequency of E will be 2, L will be 1, and O will be 1. So let us just iterate over the pattern, I less than PL I plus plus, and I can say okay, frequency of pattern of the current character. Okay, whatever is the current character. So char ch equals to pattern of I, and I can say okay, frequency of pattern of ch plus plus. So that is the next step. Now we need to do something like a sliding window. Okay, so third step is sliding window, and it will have two cases, expansion and contraction, plus update the minimum length window during this process. Okay, so multiple steps in this part. So let us iterate over this entire string. Okay, we will consider the first character, include it in the window, then go to the next character, include it in the window, and keep on doing this till you get the first string that includes all the characters of the given pattern. Okay, that is something part of a expansion process. For int I equals to 0, I less than SL, okay, I plus plus. So what we are going to do, we are going to include the current character. Okay, so current character is s of I, string of I, and I'm going to say okay, in my frequency array, that in the frequency map that is for the string, for the given string I'm going to increment the frequency by 1. Now what can happen, suppose you got this particular h, okay, and now your frequency map looks something like this for the given string. Okay, so it is all zeros, and frequency of h is 1 and all zeros. And now suppose your pattern is also same, so your pattern is, let's say, h, your pattern is h. What do you need to do, you need to see after doing this update whether my this map and this map, uh, okay, so I need to make sure that this pattern is contained inside this string or not. Okay, even if this frequency is 2, then the result is true because it contains hh and it contains h, so this pattern lies in this particular window, so it's going to be true. Some of the characters may have a higher frequency than needed, so we need to consider those cases as well. Okay, so what I will do, I will do a check. So how do I check? So I will check uh, whether the count of characters. Okay, in this case how many characters I have 4 characters. Okay, so I will maintain a count. So every time I match a e, I make my count as 1. I got another e, I make my count as 2. I got another l, I make my count as 3. I got another o, I will make my count as 4. So I will maintain a count of matching characters. Okay, if that count is equal to the length of the pattern, that means all the characters of the pattern have been matched. Then I will come to know that I found out a valid window. Okay, so before checking the count of characters, I need to maintain the count of characters. Maintain the count of characters matched. Okay, so how do you check if suppose you were doing a sliding window, HELLO, so your string is, let's say, ELO. Okay, so you have a h here. So does including h in the window, will it increase your count? The answer is no, because h is not present in this particular pattern. But if you go to E, does including the E increase your count? Obviously yes, it is going to increase the count. So I can check if the given character is present inside the pattern. So I have to check from the frequency map of the pattern. If frequency map of the pattern corresponding to the given character is not 0, and frequency of the given character in the string map is less than equal to frequency of pattern of ch, then I can increase the count. Let me explain you this particular line. Okay guys, here is a little tricky thing that I'm going to explain you. So I made a variable count. Okay, so count stores the total count of characters that I have matched. Okay, for example, if my string is, let's say the string is HEELLO, okay, and let's say your pattern is like this. So pattern is, let's say, ELO. Okay, so firstly we made a frequency map of the pattern. Okay, so that is your FP, and that basically stores all zeros. Frequency of E is 1, frequency of L is 1, and frequency of O is 1, and so on. Okay, and rest all are zeros. Then what we do, we say okay, count is 0, so this count is going to maintain that how many characters we have matched. Okay, if your pattern is ELLO, then we need to match 4 characters, and we'll make sure that these 4 characters are 2 L's, 1 O and 1 E. Okay, that is we are going to ensure by using this condition. Okay, let me tell you what we are doing. So suppose you start iterating over this string, you get an H, you say okay, frequency of H plus plus, so you make another array that is your frequency of string, and you say okay, H is now having a frequency 1, you go to the next index, but you do not increment the count because H is not present in the pattern. Okay, so this is what I check. If I see the pattern does contain an H, only then I will increment the count of characters that are going to be matched. So this count will not increase, so count will remain 0 because H is not there in the pattern. Okay, next I go to E. So as soon as I go to E, the frequency of E becomes 1, and also I see that uh, in my pattern the frequency of E is 1, and after including the current E, my frequency is also set to 1. That means frequency of E in this array, that is 1, and in this array, that is also 1. So if this becomes less than or equal, then I will increment the count. Okay, so count will be now 1. So I got one matching character, that is E. Next time I go to another E. Okay, so what happens, I see. Okay, so in this case, when I get this particular E, so this particular E is not present in the pattern. Okay, so ideally I should not increment the count. So what will happen, when I will go to this particular E, I will see that frequency of E in the character array will now become 2 because of this instruction. So this frequency of E becomes 2, and this is actually greater than frequency of E required in the pattern. Okay, so the string contains 2 E's, but the pattern requires only 1 E's. So this frequency is now higher, so I do not increment my count, so my count remains still 1. Then I go to L. Okay, so I got an L, I make frequency of L as 1, and I see this frequency is 1 and the required frequency is also 1, so this becomes a equal case, so I increment the count, so count after scanning L becomes 2, and I get another L, so frequency of L becomes 2, which is higher than the frequency that is required in the pattern. So pattern requires only 1 L, so I do not increment the count, so the count still remains 2. Next I get the character O. Okay, so what I will do, I will say okay, frequency of O will become 1. Okay, the frequency of O will become 1, and I say the count will become 3 because the required frequency of O in the given pattern is 1, and the current frequency is also 1, so I include this O, okay, in the count, and count becomes 3. So you can see after scanning till this particular point, you will get the first window that contains the word ELO, that contains all the characters of this given string, EL and O. So here you can check if count now becomes equal to the length of the pattern, that is p, then you can start doing contraction. Okay, then you can start contracting from the left. Okay, so we will start removing unnecessary characters. So h is not needed, we will remove it, and then we will see if after removing this particular e, are we able to solve the problem. The answer is yes. Okay, because after removing the c, the frequency of e will be 1, and still you can see elo can be fitted inside this, okay. So this way you will get the final output as ell. So let us write the next part of the code. I hope things are clear till this particular point. So let us see if all the characters match. I can check if count is equal to p of l. Then what I will do, I can start shrink the window. Okay, we can start shrinking the window from the left. So I will keep a left pointer or a start pointer that that is starting from the extreme left. So int start equals to 0. Okay, so start is nothing but the left pointer for shrinking the window. The right pointer is I itself. Okay, so we are using I to expand and we are using start to shrink the window. So start shrinking the window. So now how do we shrink the window? Okay, so it's going to be a loop. So you're going to remove you're going to loop to remove all unwanted characters. That's what you're going to do. So what I'm going to do here is while, let's say, whatever is the current character, that is temp, that is equal to s of start. So okay, let me just explain you what we are going to do. While the frequency of the given character, that is the temporary character, h is, in our case it is going to be h. Okay, so we have the window till this point, and this is what start is, and temp is going to store h. This is temp also, and while the frequency of temp is greater than so either this is not present in the pattern, then we can just ignore this h. So what will be the condition? If while frequency of temp inside the pattern is a 0, or its frequency is higher than it is required. Okay, so if the string is HELLO and you require ELO, then you can see frequency of E is 2 and the required frequency is 1. So you, when you go to this particular E in the next step, you can simply say I can reduce it because only 1 is required, and till now I have 2 E's which are present in this window. So this contains 2 E's. I can remove this E and make it as 1 E. Okay, so while frequency of temp is equal to 0, frequency of the current character in the pattern is 0. That means this h is not present in the pattern, or it is present but its frequency is higher than required. Okay, so fs of temp is required is greater than fp of temp. Okay, in such a case, what I'm going to do, I'm going to say just ignore the current character. Okay, so I'm going to reduce its frequency by a factor of minus. Okay, so what we did, frequency of h was 1, so I made it as 0, and next time I go to E, so how do you go to E? By doing a start plus plus. You do start plus plus as well. So you go to E and you say okay, E is also not required because of this condition, so frequency of E goes from 2, it becomes 1. And one more thing I have to do is I need to update my temp variable, because that is equal to s of start, so that we have updated outside the loop. This should be done inside the loop as well. So now temp is going to store E, and we are going to discard E. Next time we go to E. So when we come to this E, we say okay, frequency of E is 1 and the required frequency is 1. So we do not enter this loop. We come out of this loop. Okay. So we come out of the loop at this particular point. And once you are out of the loop, you got a minimum window. Okay. So you got this window ELLO. So what is the length of the window? So let us calculate the window size. So int window length, that is going to be equal to, the ending point is I, starting point is start, and how many numbers you have from start to I, including I and start. So that is going to be I minus start plus 1. And you can check if this window length is let's say, so in the beginning, yeah, I have initialized it. So let me say in the beginning the window length is going to be int max. Okay. So if window length is, let's say, okay, let me just call it as min length. If the min length, if the current window length is less than minimum length, then I'm going to update my answer. So I can say okay, we are going to have something like we got some window, and you can say minimum length should be equal to the window length and the starting index of the window. So I'm also going to store the window. So let me say I have a starting index here. Okay, that is equal to -1. So I just note down the start index of that particular window and the length of the window. So start index is going to be start. Okay, that's it. And finally, once we are out of this particular loop, so at this point we are out of this particular loop. That means we have scanned all the characters, and from here we can check if start index is -1. That means no such window found, and we can say return none. Otherwise, we can say return a smaller substring. So string answer is going to be s dot substring that starts from the start index and continues till the minimum length. Okay, so substring method 2 accepts two parameters: the starting point of the substring, let's say this start, let's say this points to E, and how many characters you have to take from this starting point, that is the minimum length. So we will return the answer from this particular point in the program. Okay, so build is successful. Now let us call the function. So cout find window, and we give string and the pattern. That's it. Build the code. Yeah, pattern is nothing but P. I hope you will get this point. This part is easy, and this part I have already explained what we are doing. So we are removing the all unwanted characters by shrinking the window from the left. So let's see in the output. So this is minimum window. So I get LOEAE. So LOEAE. Is this the smallest window that contains two E's and LO? LO is present. This is not there. I think it looks fine. We can try with some more examples. Let me just say hello world. In this case, I should get EELLO. This should be my output here. EELLO, that's fine. Let me just make it as like this. EE O and L. In this case, it should be LEEO. Let me build the code. LEEO. So code is working perfectly fine. So I hope you got an idea how to solve this particular problem. Hi everyone, so now we will discuss a problem called as right angled triangles. The problem says given n points in a 2D Cartesian plane, we need to figure out how many right angled triangles are there such that the perpendicular or the base is parallel to x-axis or y-axis. Okay, so let me show you with the help of one diagram here. So let's say this is your Cartesian plane and there are some points in the plane. So you need to figure out how many triangles you can construct such that either the perpendicular or the base is parallel to x or y axis. Okay, sorry, both. Okay, so one of the side should be parallel to x axis, other side should be parallel to y axis. This is what the problem says. So let me give you one example. For example, if you pick this point, let's say you pick this x comma y. So now in order to construct a right angled triangle, what do you need? You need a parallel, you need a line that is having the same x coordinate as this one. Okay, so maybe let's say this is x comma y1, this is x comma y2. Okay, so I'm just labeling the first coordinate as x because they are lying on the same x coordinate. Okay, and let's say this is x comma y3, and similarly you will need something that is parallel to x-axis. So maybe for this y you need to find out points, let's say x1 comma y, x2 comma y, such that you can construct a line that is parallel to the x-axis. Okay, this is x axis and this is y axis. Now you can see clearly it's possible to draw a triangle like this. You join this line, you join this line, and you join this line. So this is one triangle. You can even join this point with this point, and you can join this with this line. This is another right angled triangle. And another thing you can do is you can pick any one of these points. Okay, you can pick one of these points to make a triangle as well. Okay, so when you can join this pivot point with this point, and you can join it with this point, or you can join this point with this point, and you can join it with this point, or you can join this point with this point, and you can join here, or you can join this point with this point, and you can join this point here. Okay, so you can see all these triangles you can form. Similarly, if you have some coordinate here, you can even make it like this, join here and here, here and here. So basically it's all about counting the number of possibilities that can be there. So let me give you a very simple idea that you can use to solve this problem. So basically, in order to construct a right angle triangle for any given point x comma y, you need to figure out how many points have the same x coordinate. Okay, so if there are, let's say, 3 points that have the same x coordinate, let me just draw these points. So in all there are 4 points that have the same x coordinate, so they will lie on the same vertical line, and maybe there is one more point in the bottom. Let's say there are a total 5 points, and you can pick 4 out of these 5 points. 4 can be used to make a line because we are treating this as a pivot point of the triangle. Okay, so this is right angle triangle, this point is a pivot point. And maybe you also need to figure out how many points have the same y coordinate. Okay, that's another thing you need to figure out. So what you can do is, out of these points, so 3 plus 1, you have 4 points to choose from to create a vertex, to create a line that is vertical, that is parallel to y-axis. And out of these 2 points you can choose one point to make a triangle. Okay, so maybe I pick this point, and from here I pick this point, so you can make a triangle like this. Or you can say, no, I will pick this point and I will pick this point, So you can make a triangle like this. So basically I'm saying if there are total number of points is, let's say, n1, including the point that is the pivot point, then the effective number of points with which line can be formed would be n1 minus 1. And if there are number of points that have the same y coordinate, let's say this is n2, then leaving one point you have n2 minus 1 choices to make. So total number of triangles you can form keeping this from x comma y as a pivot. Okay, so keeping a point x comma y as pivot would be n1 minus 1. Okay, or you can say n1 minus 1 c1. Pick any one point into pick any one point from the horizontal line, so that would be n2 minus 1 c1. So this is nothing but n1 minus 1 into n2 minus 1. Okay, so now the problem boils down to finding out how many points have the same x coordinate and how many points have the same y coordinate. So this is the number of triangles you can form using this point as a pivot. So if you have n number of points, p1, p2, p3 up to pn, and each of them will have their own x1, y1, x2, y2, x3, y3 and up to xn, yn. Okay, so what you need to do, you need to maintain two hash maps to store the count of okay, so you will make a hash map for x, let's say hx. So hx of x will store the number of points that have the same coordinate. Let's say it's like a frequency, so maybe let's say x coordinate is 2. So how many points have the x coordinate as 2? So that will basically give you how many points lie on the same vertical line. And another hash map h of y, that will store how many points have the same coordinate y. Maybe let's say this is 3 for a given x comma y. Okay, so what you need to do, just iterate over all of them and put the x values in the hx hash map. Okay, so it would be, let's say, unordered map of the type int comma int. Okay, the first int gives you the value of x coordinate and the second int gives you the count. Similarly, you make another unordered map for y. First gives you the value of y and second gives you the value of count of y. How many points have the same y coordinate? So once you know this, you just iterate over all the points, find the number of triangles that can be formed with the given value of x and y. So hash map will basically give you these values n1 and n2. Okay, so once you know these values, take the product. This will give you the number of triangles for a given point, and that you sum it all for all the values of x comma y and you're done. Okay, so the coding part, it's very easy. I'm leaving it to you as a homework, so you have to solve this problem and code it. Hi everyone, so now we would be dealing with a very interesting problem statement. It says you're given n Cartesian points. So you have n points in a Cartesian 2D Cartesian plane. You need to find the number of axis parallel rectangles that can be formed by them. So let's say this is the vector of points that is given to you. You need to find how many rectangles you can form using these points. So you can see in this particular diagram, so the points are given like this. Okay, so you can have points anywhere in the grid. Okay, and you need to find out how many rectangles you can form. So basically for this example, all these points are given, right? So these are the points that are given to us and we want to know how many rectangles we can form. So now you can clearly see there are multiple ways to form rectangles, and these rectangles should be axis parallel. That means their sides should be parallel to x-axis or y-axis. Okay, so let us try to draw a few rectangles that we can draw. So one rectangle would be like this, another could 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 be like this. So you can see we can form a different number of rectangles using this, right? So guys, let's see how we can actually find out how many rectangles are there, right? So one very interesting property that you need to note here is you need 4 points to form a rectangle, right? 4 points to form a rectangle. Okay, and if you do something like a brute force, you pick you have n points, you have nc4 options, or that would be of the order n4, and you need to check whether those 4 points form a rectangle or not, right? But what I will do, I will pick actually 2 points, right? The 2 points that are diagonally opposite because of one interesting property that we have. So if I pick this point as x1 comma y1, and the diagonally opposite point of the rectangle is x2 comma y2, okay, and let's say this is the diagonal like this. So what you can infer from this is, if you know these 2 points, the other 2 points are automatically fixed. The other 2 points are automatically fixed. So can you guess what would be the coordinates of these two corners, right? So what would be the coordinates of, let's say this is point P1, this is point P4, or let's say this is point P2. What would be coordinates of point P3 and P4, right? So P3 must have same x as P2, so the coordinate would be x2. And what would be the y coordinate? It should be same as P1, so that should be y1. Similarly, for P4, the x coordinate should be as x1, same as this one, and the y coordinate should be same as this one, that should be y2, right? So you can see, if you just fix these two corner points, the other two corner points are automatically fixed. So what we need to do, we need to iterate over all pairs of points, okay? And let's say you pick the point P1 in n ways, you pick the point P2 in again n ways, and we have n square options to build a rectangle, but all of them will not be valid. Option will be valid only if P3 and P4 point exists, right? And how do you check whether a point P3 is present or P4 is present? So this can be done easily using a hash map or something like that. Okay, so if you just hash all the point objects, and then you can easily check whether this point exists or not, right? So to hash all the points, what I will do, I will use a set data structure, and I will create a point object, right? I will create a point object that will create two values, x and y, and I will create a set of points. Okay, I will create a set of points, and from this set I can use the s.find function to check whether a point is present or not, right? So why I'm not using a unordered set or a unordered map? Because point is a custom object, so when you deal with the custom objects, it is easier to work with containers like sets, or yeah, because of because unordered map does not know how to hash a point object unless you provide an implementation. Okay, so if you put the point as a key, point object as a key, then you have to also tell the unordered map how to create a hash value out of this, right? That is something, it's going to be a bit tricky in implementation. So we will just use a set, and what set does is internally it uses a tree like structure, right? And what you need to do, you just need to give a comparison function to compare 2 point objects. Okay, so if point is 2 comma 10 and there is a point 2 comma 8, then it should go in the left of this, right? So set is also fast, right? So it works in log n time. So lookup will be in log n time, and iterations will take n square time. So what we will do, we will iterate over all possibilities, and we will try to see what all pairs can give you valid rectangles, right? So suppose you pick this point, then the diagonally opposite point can be this one, right? It can be this one also, it can be this one also. If you pick this point, diagonally opposite can be this one, or this one, or this one. So one potential problem will arise is, you will be counting each rectangle twice, right? So you will be counting each rectangle twice. Why? Because when you pick point P1, you get P2, but when you pick point P2, suppose you are iterating like this. Okay, so you have n number of points, okay, and the other array is also same, right? So let's say this point is P1, and this is P2, and this is P2, and this is P1. So when you pick P1, you get a point P2, and when you pick P2, you may again get a point P1 or something like this, right? So we have to avoid double counting also, right? So what we will do, finally we will calculate all the rectangles, and we will we will reduce our final answer by a factor of 2, right? So it's like a brute force solution that we are trying to optimize using a data structure. Okay, so that's what we are going to do in this particular problem. So let us try to write some code. So let us start by taking input, right? So what I will do, I will create a class called point that will store two things, x and y, and maybe make them public, right? And we will have a point constructor, doesn't take anything. We have a point constructor that takes x and y. So we say, okay, this arrow x equals x, this arrow y equals y, and what else we need to do? That's it. I think that is sufficient. And what we need to do is to create a point here, right? So I can say point p that is initialized with x and y that we take in from the user input. So I'm taking m points as input, right? So let's see what else we can do. So input is done, right? So what I do, I will actually create a vector of points, right? So in order to store all the points, I'll create a vector. So I can say, okay, uh, let me call as vector of point, and let's call it as coordinates. And here I can say coordinates dot push back p. Okay, so that completes the input part. Now comes the main algorithm that we are going to write here. Int count rectangles. What we get a vector of points called as coordinates. Okay, and we get yeah, m is not needed. We can simply say, okay, the number of points is nothing but coordinates dot size, or that is the number of points that we have. So now comes the brute force approach. So what we will do, we will first insert all the points in a set so that we can have a efficient lookup. Insert all points in the set. So set of point, and let me call it as s. Now this is a custom object, so when you create a set of a custom object, you also need to supply a comparison operator. As I said, that internally uses a tree like structure, and it needs to compare whether the current point will go in the left or go in the right. So you can write any comparison operator by yourself. So what I will do, I will make a comparator that will compare the coordinates based upon their x and y coordinates. Okay, there's a bool operator. So what we get, I get point p1, point p2. I need to make a comparison. If x value is same, then we make the comparison on y value. Otherwise we can simply make the comparison based upon x values. Okay, so p1 dot x less than p2 dot x. So this is a compare function. So compare class, so we provide this compare class to our set, something like we have done in priority queue as well, right? So we are comparing 2 points based upon their x and y coordinates. If the x coordinates are same, we basically compare the y coordinates. Okay, this is how the values are going to be inserted internally in the tree that is made by the set object. So what is the next thing that we need to do? We need to run 2 loops. Okay, run 2 loops and create a variable answer just to count the number of rectangles. Okay, so let me say for auto it equals to s dot begin, it not equals to. Okay, so let me say what we are going to do. So let's say these are the points that are inserted in the set. So first loop will run from this location to this location. So and then and the second loop, so if you are at this index it, next loop will actually start from this location, right? Next location jt will start from it plus 1. It will go till the end, right? So I'm not going till the end, I'm going one step behind it so that I get something for the next point. Okay, so for the first iteration I'm saying go till the second last point. That's what I'm going to do, right? So let's see how we can go till the second last point. So it should not be equal to s dot end. So that means uh, yeah, so it should be here, it should be previous of s dot end, right? So we should not reach the last point, so that means we will stop at the second last point. And for auto, jt equals to it plus 1, right? So set is a associative container, right? Oh sorry, set is uh, container that is not linearly indexed. Okay, so in that case, if you want to move an iterator to the next step, you have to use the next function. Okay, because it plus 1 makes only sense when the underlying container is linear, right? So we say, okay, take the uh, jt pointer to the next position. Okay, and jt should not be equal to s dot end. I do jt plus plus, right? Okay, so what we can do, we can pick the first point. So first point, p1, that is given by star of it, we dereference the pointer. Second point is star of jt, we dereference it. And if both of these coordinates are same, right? So somehow if p1 is equal to p2, okay, okay, not exactly same. So let me explain you. If you pick a point, okay, and then if you get a point that is in this same axis, like here or here, then this cannot be a valid endpoint of a diagonal, right? Because if the x coordinate is same or the y coordinate is same for these 2 points, they cannot be valid points, right? So I will skip all those points which lie in the same horizontal or same vertical line for a given point. So I need to skip them. So what I will do, if p2 dot x is same as p1 dot x, so either the x coordinate matches or the y coordinate matches, we have to skip all those points. So I'd say, okay, continue, don't do anything. Otherwise, let us try to create points for the other 2 points, right? So we have p1 p2. So let's see what we have done. So this is p1, this is p2, and we need to get the points for p3, and we need to get the points for p4. So what values it should be? So let's see, let's try to figure that out. So x2, or maybe let's say let me create a point p3, right? So point p3 should have a x value that should be equal to it arrow x. Okay, or let me say uh, p1 dot x. Okay, so for p3 the x value should be same as p2 dot x, and y value should be same as p1 dot y. And point p4 should have value such as p4 should have p1 dot x and p2 dot y. We need to look for these points in the set data structure. So what we do, we put a condition here: if s dot find p3 not equal to s dot end, and s dot find p4 not equal to s dot end. Okay, so we found a valid point. So if you want to store all the coordinates, then you can store, otherwise you can simply do answer plus. And finally, from here you can return answer by 2. So it's a brute force way that we optimized using a set data structure, right? So we avoided 2 loops here, right? So that's what we get here. Okay, and now we need to run our code. We need to call the function as well, right? Okay, so one thing I missed here is I forgot to add all the points to the set. So we should first iterate over all the points that are there in the coordinates vector, and we should insert them in the set. I should do s dot insert p. So that is the first step that got missed here. And Rest of the code looks fine. So let us build the code, and you can see there is only just one warning, no errors. That means we can run this code. So for this code I am giving input from a file. Okay, so the expected answer for this input is 6. You can verify it yourself. So let's run this code, and you can see we are able to get 6 rectangles uh, from this given input, right? So I hope this solution is clear. So what we did, we iterated over uh, all pairs of points, and the two other points p3 and p4 we tried to construct, and we try to look up for those both points in the set. That gives us a lookup time in order of n, and if we find both of the points that are there in the set, okay, so what we do, we iterate over these and we look up for these. If both of them are present in the set, we increment our answer, and finally we will get the answer as 12. For this test case we divided by 2 so that we avoid the symmetric cases. Okay, so something like this. So yeah, so symmetric case would be like this. So this is one diagonal, right? So next time a symmetric case would be of this form. If you get this diagonal, then also you will be constructing the same rectangle, right? So we have already avoided this case. We are making sure that p2 starts after p1, right? So we are not considering this case where p2 can be p1, but this is a symmetric case where p3 and p4 can be found out using these for loops, and p2 and p1 and p2 are coming from the set. So that is why we are dividing the answer by 2. I hope you got this point, right? So in the initial explanation I missed this point, but now it's clear that this is something we have to actually do here, right? So that's all for this video, guys. Thank you.
Hi everyone, in this video we are going to implement one new data structure, and we will discuss one motivational problem, that why we should learn this data structure called try. Okay, so let's focus on what this problem is. So let's say there is a problem in which you are given a list of strings. Okay, so let's say you have certain strings like this. You have a word no, you have a word, let's say, not, you have a word called news, you have a word something called hello, you can have, let's say, apple, and so on. Okay, so let's say you're given a paragraph that contains a lot of words, and after that you will get certain queries. Okay, so the queries will be like this: tell me if there is word not present in the paragraph or not. Okay, so if that word is present, so you will say okay, it's present. And let's say someone says, tell me if the word new is present in the paragraph or not. So you will say okay, this is not present, so the answer is going to be false. Okay, now there can be multiple ways to handle this thing. So one way is you can use a brute force approach. Okay, so that's going to take time. If the entire length is n and this word length is m, so it's going to take order n into m time. Okay, second way is you can use hashing. Okay, you can hash all the words. Let's say if there are n1 number of words, then you can just do hashing in order of n1 time for all the words. Okay, that is equal to the number of words in the sentence. So hashing will allow you to have a direct lookup. So that is one approach that you can use. Another approach that we can build up is we can build a tree. Okay, we can build a prefix tree, and this prefix tree is called a trie. Okay, so let's see how we can build this prefix tree. So let's say you have this word no, then you have word not, then you have news, and so on. So you will have a root node. Okay, let's store null at this point, and from this root node you will start building a tree of characters. Let's say you want to insert a word called no, so you build a tree. The first node contains n, the next node contains o, then you add a word called, let's say, not. Okay, so you are at this point, you see if n is present, so you go at this location. So if you see o is present, you go to this location, and then you add another node that contains the word t. Now you also want to identify what are the words present in this tree. So clearly we know there are two words, One word is no, that starts from here, ends here. Another word is not, okay, that starts from here, ends here. So that means we also need to mark the node where a word is ending. So those nodes will be called as terminal nodes, okay. So we have to mark terminal nodes because at that point a word is ending. Also, these type of nodes may occur in the middle also, because some word may end in the middle. And why it's called prefix tree? Because we two words have the same prefix, so they lie in the same branch, okay. No and not have the same prefix, so they are in the same branch. And let's say the word is news, so you will add nodes like this, okay. Suppose the word is apple, then you may say, okay, this is how I am going to add it in the tree. Suppose the word is ape, then what you can do, you can say, okay, ap is already there, so I add another node in this point, and let's mark the terminal nodes as red or green, okay. So ape is a word in the tree, apple is a word in the tree, news is a word in the tree, not is a word in the tree. And now you can have queries, okay. So you can do insertions, okay. You can insert new words, and you can also do queries. That means you can search if a given word is present in the tree or not, okay. Suppose I'm interested in finding if a word not is present, then what I need to do, I need to just traverse this much part of the tree, and this will just take the time equal to number of characters, okay. Suppose the entire length of all the words is 10 lakh, okay, but this word has only 3 characters, then you can just search in this much time, okay. You can just search this in order of one time, or order of string length time, okay. That is the length of the word. Now the question is, how do we implement this, okay. How do we implement this tree like of a structure? So let's see how does a node structure will look like, okay. So a node will have a certain data. That data can be an integer, character, boolean, object, anything, okay. Then we also need to maintain some kind of mapping. Let's call this as a hash map or something that maps a given character with the node pointer, okay. Suppose you want to go to a node that is mapped with a, then you can keep a mapping, okay. You can keep a map of this kind, a map of char followed by node star. So this a is mapped with this particular node, so that you directly reach this particular node without looking for all the pointers, okay, without traversing all the branches. You can directly look, okay, a is here, and in this node you will keep another hash map that will point to other nodes. If there is a node p, then this gives you the address of p. If there is a node e, this also gives you the address of e, and so on. So this is one thing that you need to keep. You need to keep data, you need to keep a hash map, and one boolean value to denote whether this node is terminal or not, okay. So we will need to keep these three things to implement this tree like data structure. And it's also like a generic tree, okay. So some students were asking me, sir, what's a generic tree or what's a NV tree? So this is nothing but a generic tree, okay. If you want to implement a generic tree, you can implement it like this as well, okay. Or you can keep an array of pointers also. But in our case, keeping a small hash map in every node will be useful, okay. So we are going to keep small hash map objects inside every node, okay. So this is how the try is going to function. And another useful application that can be done in real life, okay. So let's say you make a try of all phone numbers, okay. Suppose you have 1000 contacts in your phone, or maybe 10 lakh contacts on Truecaller. What you can do, you can make a try like this, okay. You can say there is a number 9817, and this belongs to a person called X. There is a person phone number called 9819, this belongs to a person called Y. There is a phone number 9865, 9866. Because in phone numbers you can see lot of prefixes are going to be same. Only if one of the digit changes, the name of the person whose phone number it is, it's going to change. So if you want to make a large directory of phone numbers, a try would be a better option than a hash map, okay. And if you want to just store phone numbers, let's say of 1000 contacts on your phone, a hash map would be a better option, okay. Because a very huge try is going to take a lot of memory, okay. And if you have fewer contacts, a hash map is a better option. And as the number of entries are going to increase, the number of collisions in the hash map are also going to increase, and it may lead to degradation of the performance. Okay, so it's recommended that you go with the try part if the data is huge. So sometimes this is also asked in interviews. If you want to implement a phone book, what would you prefer? Okay, so you should discuss the trade-off between a hash map and a try. Okay, in that case, similar to what we have just discussed. Okay, so let's talk about the implementation next. Okay, so let's dive into the implementation. Okay, so I would be using the online ID. Alright, so what we are going to do is we are going to include one header file that we will be using, that's called unordered map, and set is not needed for this one. Okay, so let's start by implementing a node. Okay, so how do you define a node? As we just saw, to define a node, we will make a custom data type called node, and it will have three things, and let's see what those things are going to be. So this is how we can define the node, and we need to define the data members, one data member to hold data, one unordered map to store the mapping of char with the node star, and let's call it as children, and one thing to denote if a node is terminal or not. Okay, so we keep a boolean variable here, and let's say we have a node constructor that accepts a given data. Okay, when you're going to create a node, you need to define what data it will contain, and by default we will keep the value of terminal as false, and that's it. Okay, so what we are going to do next is we are going to implement the try. So try class will look something like this, and we now need to think what data members a try will contain. Okay, so a try is going to contain only the root pointer. Okay, so it's going to contain a root pointer that will point to the root node, and this node will must be initialized with some garbage character, or let's say null character. Okay, and this will keep a hash map to the nodes which are at level 1. First level nodes will keep a hash map of node pointers which will point to nodes on level 2, and so on. Okay, something like this we are going to do. So let me say there is a node pointer called root, and maybe a count denotes how many words we have inserted in the try, and let's make a try constructor. So when you're creating a new try, you can say, okay, root is going to point to a new node whose data is going to be null. Okay, and count by default is going to be 0, and then we can write a function that is going to insert a word in the try. Okay, so let's say we are getting a word w, and we want to insert this word into the try. So the way we are going to traverse is we are going to start traversing the tree from the root node, and then we are going to iterate over all the characters in the given word. For example, the word is no, not. Okay, let's say the word is no. Okay, so I say, okay, root from in the root node I will check if there is a pointer to the node n. If it is there, I will go to that node. If it is not there, I will create a new node. Okay, suppose no word is inserted in the try, and now I want to insert the word not. Okay, so from root node I will check if n is there, from n I will check if o is there, from o I will check if t is there. So clearly there is no t in this, so I will create a new node, and I will save the address of t in this particular node. Okay, so this is how we are going to proceed. Okay, so we are going to iterate over a word letter by letter, and at every step we are going to check if the current node exists or does not exist. Okay, so let's say current character is w of I, and I can say if temp arrow children dot count of ch. Okay, so okay, now let's see what is there. So temp is at this particular node, that is currently root node, temp arrow children. Okay, so we are going to access the children hash map of this node, and we are going to call the count function. So count function returns 0 or 1 if a given key is present in it or not. So I'm checking if n is present in it or not. So if it is present, then I will go to that node. Okay, then I can say, okay, move temp to that node. So temp goes on temp arrow children of ch. So right, so this is the hash map, and since temp is a pointer, you need to use an arrow to access this hash map. So I'm going to say, okay, n is mapped with some address, let's say 0xffcc. So I want to go to this address. I want to go from this node to a node that is containing the value of n. Okay, so this address is mapped in this hash map. Okay, and I say, okay, take the temp pointer from this node to this particular node. Okay, so that I can look for O now, something like this. But if this node is not there, I can say, okay, I'm going to create this node. Let's see how we can do this thing. So I can say, okay, there is a temporary node called n that's going to point to a new node, and I can say, okay, store the address of this node in the hash map. Okay, corresponding to the key given by the ch, and we can say, okay, temp equal to n. Okay, so what I'm doing here, suppose at this point you're looking for a node n and you do not get a node. So I say, okay, let's create a node n, and this address will be stored in the key corresponding to the node ch, and this n goes here, and temp comes to this particular node. So this temp comes here, and now you can go to the next character using I++. So what we do, if the node is there, we go to that node. If the node is not there, we create that node. And in the end, when the loop is over, that means we are at the last node, and last node for that word will be a terminal node. So we mark it as a terminal node. So this is how the insert function is going to work. Similar thing we can do for the find function. We can say, okay, bool find. There is a function called find that we are going to implement, and find function is going to be relatively simpler than the search function. That will only need traversing the tree from root to bottom. So I can say, okay, let's go to all the characters in the given word till w of I is not equal to null. I say I++, and then I can say, okay, char ch equals to w of I, and if temp arrow children dot count of ch. Suppose I'm looking for a node n, and it happens that from a given node, the count of node n is 0. I can say that word is not present. Okay, so what I'm saying, let's say there is a try and you have a word, let's say not here, and you say, okay, I'm so searching for a word called apple. Okay, so you ask this node, do you have a? It says no, count of a is 0. So that means we should return false. Apple is not present in this node. Otherwise, if it is present, so we can go to that node and ask for the next character. Okay, so I can say, okay, go to that node, and this is how we can go to that particular node. And what can happen in the final case, suppose there is a try and you have the word not in the try, and the word no is not present. Okay, this is a terminal node, so you start traversing, you reach this particular node. So you want to check if the word no is present in it or not. So clearly you will end up at O, and if O is a terminal node, you will return true. If it is not a terminal node, you can return false. So I can say, okay, at whatever node I am ending, return true or false depending upon if that node is a terminal node or not. So I can say return if temp is terminal, and that's it. Okay, so this completes the two methods of the try class. And one final thing that we are going to do here is to make a main function, and we are going to make a try. Okay, so let's say there is a try called t. Let's say there are some words that we want to insert in the try. So let's say a is there, hello is there, not is there, news is there, and let's say apple is there. Okay, and let's say you want to search for a given word, that we will take input. So I can say, okay, for int I equals to 0, I less than 6, I plus plus, I less than 5. I can say t dot insert words of I. So I add all the words to the try, and now I can query if the word is present in the try or not. Okay, so if t dot find w, then let's see in w, then we can just see out word is present. Otherwise we can say this word is not present. Okay. So let's try to give some input. Let's say the word is apple, and let's run the code. Yeah, so this must have number of columns in this case. So you can see apple is present in the try, and suppose I change the word to no. So clearly I have inserted the word not, but I have not inserted the word no, so it should be absent in the try. Okay. And the good thing about try is we are able to make these queries in almost constant time because the word length is very small. Okay. So I hope you got the concept of try, and this was something very useful in certain problems. You can solve those with tries, and we have covered those problems in the data structures course as well. And that's all for this video. Thanks a lot. See you guys in the next video.
Hi everyone. So in this video we will be discussing a problem called as unique prefix array. So given a list of words like this, what you need to output is unique prefix for every word. Okay, for example, you have this word cobra, and now it has lot of prefix. Okay, so prefix is nothing but a starting point of the string. So if you have a word cobra, then you have a prefix called c, you have a prefix called co, you have a prefix called cob. So you have the lot of prefixes, but you want to output a unique prefix that is also smallest. Okay, so in this case the smallest prefix is c, and that is unique for all the words. Okay, so it does not appear in any other word. For example, if you had a word car, in that case c is also a prefix for car. So in that case, what prefix will we will pick for cobra? We will pick the prefix as co, and for the car we will pick the prefix as ca because it is unique. So there is no other word that has the prefix as co or it has a prefix as ca. So let us assume we do not have car as of now, so the unique prefix would be c. And let us see this example. So we have the word dog, dove and duck. So in dog, can we have d as a prefix? We can't have, because both dove and duck, they also have d as a prefix. Can we have do as a prefix? So clearly you can see do is also a prefix in dove, so we can't have do as a prefix. So the answer in this case is going to be dog. For dove, can we have d? No. Can we have do? No. Why? Because both of them are occurring in dog. Can we have the word dov? So yes, we can have the word dov as the prefix. And for the duck, word duck, we can't have d, but we can have du. So du is the prefix for duck. So now you may think of different approaches. You may think of a brute force approach that we have just dry run it, and as you know, it's going to be very inefficient. So brute force we won't discuss, but a very good idea here is from the word prefix. Okay, so whenever you have problems in which the word prefix comes, so many of the prefix problems can be solved using tries, because try is also called as a prefix tree, and it stores the common prefixes for many different words. Okay, so let us try to build a try out of it, and from that we can get an idea how we can solve this problem using a try. So trie is also called as a prefix tree. So let us build a trie out of these words. So let's see, this is the root node. Then we have the word cobra, COBRA, and A. Okay, so A is the terminal node. Then we have the word dog, DOG, and then we have the word duck. So dove, DOV and E. And then we have the word duck, DUC and K. Now this is the trie. Now given a word like cobra, how do you find the prefix? So basically, you don't want, when you will traverse the trie, you do not want branching from that. For example, if you also have the word car, in that case, car would look something like this. So you can see there is another word that is starting from C, or let us say, let me just give you one more example. Let us say you have the word as cobras. Okay. So in that case, cobra word will not have a common prefix. Okay, so answer for the cobra would be -1, and for the word cobras, the common prefix would be cobras. Okay, because that does not appear in any other word. So answer for this would be cobras. So you can see either there should be branching, or there should be one or more words that are ending in that particular branch. If I just show you here, there is a word cobra and there is a word cobras here. Now there are two words that are lying in this branch. Okay, so that means we need to handle this case as well. Okay, but before that, let us discuss what would be our logic. Okay, so basically we want to output a prefix that is unique for a given word. That means the number of words starting from that particular node should be exactly 1. For example, if you have dove as a prefix, so the number of words that are starting from V should be exactly equal to 1. Okay, so so what we can do, we can actually count how many words are lying in a from a given node. How many words are starting from a given node? So count number of words starting from a given node. From given node, and from a node, if we see the number of words that are starting is 1, or this node is a part of a word and the remaining branch forms only one word, then we can say, okay, this is going to be the prefix. So let me give you example of this. So let's say we inserted cobra in the trie, so we inserted frequency with every node. Okay, and later on, let's say we inserted the word cobras, so we will traverse this trie, and what we'll say, we will update the frequency as 2, and the frequency of S would be 1. So then we inserted, let's say, dog, so D came once, O came once, G came once. Then we inserted the word dove, so D came twice. So that means D cannot be a prefix because there are two words which are starting from D, or D is a part of two words, you can say. Then came the word O, so DO cannot be a common prefix because it is part of two words. Then came the word V, so the frequency of V will be updated as 1, and then came the word E, so this frequency will be also 1. Then came the word duck, so you can see DUCK, so all these frequencies would be 1. So these frequencies you can maintain while doing insertion in the trie. Okay, so when you're building a trie of these nodes, and you know the time to build the trie would be linear in terms of number of characters across all the words. So you will get this kind of a data structure in linear time, and if you now want to do a query, just iterate over all the words. You want an answer for cobra, traverse the branch of cobra and find the last node with frequency 1. So there is no such node, so the answer would be, in this case, -1. You want the output for dog, traverse the branch of dog and find the last node with a frequency of 1. So obviously this node is dog. Then traverse dove and find the last node with the frequency of 1. So obviously V is the last node. Okay, so last means from top to bottom, the very first node that you encounter is going to be the ending point of that particular string. So from here you can output the word dov, and similarly you can output the word du for the word duck. So I hope you guys got an idea how to approach this problem, and implementation is something that you can write yourself. Hi everyone, so in this video we will be discussing a very interesting problem, and it's bit challenging, bit hard as well. So the problem is maximum XOR pair. Okay, the question says, given a array of elements, you need to find a pair with the maximum XOR. For example, you have n elements in this array and you need to find out a pair such that the XOR of these two elements is maximum. So in our case the output is 5 XOR 25, that is equal to 28. So this is 5, so 0 0 1 0 1, and this is 25, that is 1 1 0 0 1. So if you carefully do the XOR here, so 1 and 1 XOR 1 is 0, so this is 0, this is 1, and this is 1, and this is 1. 1 2 4 8 16. So you can see this answer is going to be 16 plus 8 plus 4, that is equal to 28. So we have converted this number from binary to decimal. So when we talk about XOR, it's going to be a bitwise XOR, and you know the rules of bitwise XOR. So 0 XOR 0 is 0, and 1 XOR 1 is also 0. So XOR of two same bits is 0, and XOR of two different bits is always 1. So in order to maximize the XOR, we need to do two things. Okay, so firstly, let us say this is our answer. Okay, and in order to maximize this answer, what we need is, we need more number of MSBs that are equal to 1. Okay, so we need more number of ones, and given a choice between LSB and MSB, our preference should be the most significant bit. Okay, so if you have a number like 0 0 0 1 0, or a number like 1 0 0 0, obviously this number is going to be a higher, because as you go towards right, the power of 2 increases, and that increases the magnitude of the number. Or even if you have a number like this number is going to have a higher value. So our aim is, starting from the right to left, we need to maximize the number of ones we can have in our answer. So this is the intuition. Okay, maximize the number of ones that we can have in our answer, going from right to left, or going from most significant bit to least significant bit. So obviously the brute force approach is going to take order of n square time. You are going to find all the pairs, and you can put two nested loops to do that, and it can do in O1 space as well, but that's not very efficient way of doing it. If n is large, if n is 10 per 6 or something like that, it's not going to help. So we need to do something better. Okay, so one idea is, every time a new number comes up, you maintain what is the maximum XOR till now. Okay, for example, you have a number 3, so you say, okay, the maximum XOR is 3. Next time a number 10 comes, you say, okay, the maximum XOR is going to be 3 XOR 10, because you just have two numbers. So earlier your answer is 3, next time your answer is going to be 3 XOR 10. Next time you get another number, let's say 5. Now you need to find out, 5 will make a maximum XOR with 3, or it will make a maximum XOR with 10, or how it is going to work. So you need to update your answer. So 5 XOR 3 is going to be less, so you will see 5 XOR 10 is going to have a higher value, and this is going to be nothing but 101 followed by 1010. So this number is going to be 15. So obviously this number is higher, and you can see all the 4 bits are 1. So this number is 15. So next time you get another number, you need to find out, okay, if I have this number 25, with what number this number will make a maximum XOR. So for that you need to see the bits of the numbers that have come so far. Okay, so you need to access the bits of the numbers that have occurred so far, so far. So now how we can store all the bits of all the numbers? Okay, so there can be multiple ways. One way could be you maintain a 2D array kind of a thing. One way could be you maintain a tree like a structure. So why I'm saying is 2D array won't be very much useful, because we can represent the same information using a tree as well. Okay, so you can use a 2D array or a tree, but let's see if that's going to be useful or not. So basically what you can do is you can put a root node like this, and then you can start putting these numbers. Okay, this is the number 00011, so 00011. So this is going to be a tree like structure. Then you put the next number 01010, 01010, and so on. Now you can put all the numbers from the root node. So basically this 2D array and this tree are kind of an equivalent structure. You can traverse the 2D array, you can traverse the tree, but what optimization we can do is we can see that many of these numbers have a common prefix. So we, in order to save some space, what we can do, we can save some space, okay, and we can convert this into a trie. Okay, because many of the numbers have a common prefix. For example, the first two numbers have a common prefix as 0, and so on. So this is something we can do. So now let us try to make a trie out of, let's say, these numbers up to 2 only, and then I will show you how you can find out the maximum XOR in which one of the number is 8. Okay, for example, if you already know the answer till 2, you know what is the maximum XOR till 2, maybe that is 5 XOR 25, then you can check, if I insert a new number in my array 8, then what would be the next maximum XOR that I can make using one of the number as 8. So let me just make a try out of this. So let's say this is the root node, and that's going to be null, and then I will have 0. I'm inserting 3 here, basically 0 0 0 1 and 1. So this is what I have done, inserting 3. Then I insert 10, so 10 is going to be like 0 1 0 followed by 1 0 1 and 0. Okay, then I have 5 2 zeros followed by 1 0 1, so it's going to be like this, 1 0 and 1. Then I have 25 1 1 0 0 1, so root followed by 1 1 and 0 and 0 and another 1, and then I have 2, so 2 is nothing but 0 0 0 1 0, so 0 0 0 1 followed by another. So this is what we have till now. Okay, now suppose you already know the answer till this point. Okay, so every time you insert a new number, you compute your current answer. Okay, let us say our current answer is 5 XOR 25, that's going to be 28, and next time you insert a number 8, so whenever you insert a number 8, you if you need to check if 8 can form a XOR greater than my current answer with some other number. Okay, so for that, what you need to do, you need to compute 8 XOR 2, you need to compute 8 XOR 25, you need to compute 8 XOR 5, you need to compute 8 XOR 10, you need to compute 8 XOR 3, and find out what is the maximum of all these. Okay, so this is what you do in the brute force approach. But here what we can do is we can actually look at the bits. Okay, so what you do, let me write the binary of 8 here, 0 0 1 0 0. So what I need to do is I need to combine it with such a number such that I get more number of ones in my answer. Okay, so my try should be, I should be getting a 1 here. If 1 is not possible, obviously then the other choice is going to be 0. So starting from the root node, I see what is the first bit of 8, that is going to be 0. I will see, okay, can I get 1 at this bit? So yes, it is possible. So I jump to this particular node. So this becomes as 1. Then I go to the next bit of 8, that is going to contain a value 1. So is it possible, can I get 0 from this node? Obviously it is not possible. So we have only one option, that is go to this node. So we take the value 1 and this XOR becomes 0. Then I go to the next position, so I get a 0. Is it possible to get a 1 from this node? Obviously there is no such 1 present here, so what we will pick? We will pick 0. So 0 becomes 0. We go to the next bit and we say, okay, is it possible to get a 1 here? So obviously it is not, so we get a 0. We go to the next bit, it is 0, so we try to find the complementary bit, that is 1. So is it possible to get a 1 from this node? Obviously yes, so we pick that 1, and finally we will end up at the following. So you can see, using it, the maximum number that you can form is 8 XOR. This number that you have picked is nothing but 25, and this is 17. So just by traversing the bits of 8, okay, so in any number n you are going to have log n bits. So in the worst case it's going to be 64 or 32 bits, because that is the maximum number of bits present in an integer. So you can see, in just log of n time, okay, so the height of the tree, if the number is n, the number of bits is log n, and you can see you can just find the number with which it can find it can make the maximum XOR in just almost like a constant time, because let's assume every number has 64 bits, okay, because that's the maximum number of bits present in any integer. So you can almost uh, solve this question in order of n time, okay. So for every number you're doing a order 1 work, because you just need to traverse 64 bits, and for n numbers you need to do the same thing. So every time you will insert a new number, let's say insert a new number, let's say 100. So now you will check with what number should I combine 100 in order to maximize my XOR. So this is something you can easily do by repeating this step for all the numbers, okay. So I can give you a brief revision as well. So in the beginning you will have as 3, so your answer would be 3. Next time you get 10 as a number, so you check, okay, in my try I have 3 inserted, so it's like 0 0 0 0 1 1, and then you are inserting 10. So 10 has no other option but to get combined with 3, so your answer would become 3s or 10. Next time you insert 5, so you repeat the same approach. You try to find out the complementary bits. So if you find a 1, take, if the current bit is 0, try to find the 1. If it is not possible, take the 0 and do it for the next bit as well, okay. So I hope you guys got an idea, and in the next video we will see the implementation. Doing this will ensure that we end up getting more number of ones towards the most significant bit, and and we will also try to maximize the number of ones in our final answer, and this is going to give us the maximum XOR. Hi guys, so in this video we are going to look at the implementation of the problem maximum XOR pair using try, okay. So we have discussed the logic, now we are going to implement the solution. So firstly we need to create a node class that will be the node for the try, okay. So in my case what I'm going to do, I'm just going to keep 2 pointers, one for the left node. So left node, every time I will go to the left, it will signify that my node contains data as 0, and every time I go to right, the node will signify this node contains a data 1. So explicitly I'm not making any data member here, because we can actually save space. Just by knowing the direction of the pointer, we can say, okay, if we go left, it means this node is a 0 node, and if we go right, it means it is a 1 node. Then I will implement my try, okay. So a try is going to have a root node. Again, there won't be any data member, so what I make is a constructor, and in my constructor I initialize my node pointer with the node memory. So that's the try constructor. Next thing that I need to have in my try is a insert function. So suppose I'm getting a number, let's say 5, and in binary it looks something like this, and let's say it's a 32-bit integer, okay. So let us assume we are getting this number and we want to insert this number in the try, Okay, so that means we are going to insert all the bits starting from the MSB towards the least significant bit in the try. So let's write a function called void insert that is going to input a number n. And earlier when we made a try, we used to enter all the characters of the word, but here we have to extract bits out of it. So what I can do, I can first extract this bit. So this is easy. What you can do is you can find out MSB as let us assume it's a 32-bit integer. So you can say the bit, the rightmost bit is going to be n right shift 31, okay, and 1. So what you do, you right shift this 31 times, so you end up, you discard this bits and you do a and with 1, and if this result is 1, then this bit is 1. If this result is 0, and then this is 0. Okay, so if you want to extract the ith bit from here, what you can do, you can simply say n right shift I and 1. So this will give you the ith bit from right. Okay, so what we are going to do, we are going to extract all the bits and then we are going to insert them in the try. So bit is going to be, let me just put a loop. So we are assuming it's going to be a 32-bit integer in my case. So I can say for int I equals to 31, I greater than equals to 0. So you can see this loop will run 32 times, I minus minus. So I'm going to extract a bit from the right. So that's going to be n right shift I and 1. So we can check if this bit is 0, that means we need to insert a node in the left, and it is also possible that node is already created because of insertion of some other number. For example, you inserted 3 and then you insert a number 2. So the 0th node will always will be already present when you insert a 3, and when you insert a 2, you just need to go to that particular node. For example, this is the root node, this is 0 1 1, and suppose you want to insert a 2 now. So what you will do, you will go here and then you will go here. So these two nodes are already created when you create a 3. So we need to check if the left node exists or not. So if, okay, let me create a variable called temp that starts from the root. We can check if the left node exists or not. So if the left node is equal to null, what you need to do, you need to create that node. So, and the address of that node will be stored in the parent node. That is what the statement does. The new node creates that node, and this temp arrow left, the current node, stores the address of the left node, and then we go to the left node. Okay, temp arrow left. So we will have a corresponding case as well with this if the bit is 1. So else the bit is 1, we need to create a node on the right. Bit is 1. So you can check if the right node already exists, you just go to that node. Otherwise, if it does not exist, first create it and go to that node. So if temp arrow right is null, that means the rightmost node does not exist. Then I say okay, temp arrow right is going to be new node, and we go to that particular node. Temp equals to temp arrow. That's it. That's the complete insert function for the try. Okay, so that's the insert function. Next thing is we need to write a helper function to find max XOR. So before coming to that, let me just give you a quick recap of this function. So what we are doing, we are saying okay, you have a 32-bit number like this, create a try out of it. Okay, so you say okay, this is the root node, create 0 0 0 0 0 1 0 and 1. Okay, then you get some other number 0 1 0 0. So you again start creating that number like this, 0 0 and so on. Okay, so this is what we are doing here. So basically you get any number, you insert it into the try by extracting the all the 32 bits of that particular number starting from MSB towards the LSB, least significant bit. Now let us write a helper function to find the XOR. Okay, so let me say what I'm trying to do in this function is, so this is not our final function. What this will do is we will send this helper function a number. Okay, for example, you have inserted, let's say 357 in the try, and now you're going to insert 8 in the try. So after inserting 8, you will ask, okay, what is the maximum XOR that you can make with this number 8? So 8 will try to make a XOR with itself, it will try to make a XOR with 7, it will try to make a XOR with 5 and 3. So we'll try to find out what is the maximum XOR that I can make using this particular value as 8 from the current numbers that have been inserted in the try, something like this. Okay, so I'm sending this value 8 and I want to find out what is the maximum XOR you can make by using 8 as one of the numbers in the try. Now let me tell you what we are going to do. Let me say I have a variable called current answer that is going to be 0. Okay, and again we need to extract all the bits of this particular number. So I will say for int j equals to 31, j greater than equals to 0, j minus minus. Okay, what we do, we extract the last bit. So last bit is going to be nothing but whatever value we're getting is right shifted by j, and you do a AND with 1. And if this bit is 0, okay, so you extract the first value of 8. If the bit is 0, you will try to find out a complementary value of 1. Find a complementary value. So we need to find a bit 1, so that will be present on the right. So you can check if temp arrow right is not null, that means you found out a node that was 1 in the try. So you go to that node and also you add something to your answer. So you say current answer plus equals to something. So basically what happened is in 8, let's say you were getting something like this 0 1 0 0. Now you pick this digit and in your try you say, okay, is there something that is equal to 1? So yes, there is something that is equal to 1. So you go to this node and you say, okay, I'm going to take this in my answer. So when you add this bit 1 to your answer, so the effective contribution of this bit would be nothing but 2 raised to the power j. Okay, and this can be written as 1 left shift j. So I will add this contribution to my answer here. So I will say, okay, 1 left shift j would be added to my answer. Otherwise, if 1 is not present, suppose if this node is not present here, then there is no other option, you have to go to the node 0. One of these would be present. So otherwise, just go to the left node, and taking a 0 will not contribute anything to the answer, because if your current bit is 0 and you're not able to find a 1, you take a 0, so and you do a 0s or 0, so it will contribute 0 to your answer. So I'm not going to update my current answer at this particular point. So this is the case when your current bit is 0. Otherwise we will have a completely opposite case as well. So in the value, if your current bit is 0, you will, sorry, if the current bit is 1, okay, you will try to find a value, you will try to find a value whose left node is 0. Okay, you will try to find a node in which a 0 is present, because the current value is 1. So we check on the left. If temp arrow left is not null, that means we found out that node. We go to that node and we say, okay, increment our current answer by a factor of this 1 left shift j. Now what happened is, let's say you were on this bit, okay, so every time what you're doing is now you are at this node, current bit is 1, so this is your value, and in your try you're going to locate a node so that you get a 0 here. Okay, so this is what we are trying to find. If we get a 0, then 0s or 1 is going to be 1, and whatever index j is, it is going to contribute a answer of 2 raised to the power j. So that's what we add to our current answer. Else we can say that temp equals to temp arrow right, go to the right node, and that won't contribute anything to our. So this is what we have. And finally, in this function, we are going to return current answer. So this is not the complete code. Okay, so this basically tells what is the maximum XOR I can find out with the I can make out with a given value. So from here I can say okay, return the current answer. Now I will make another function int max XOR that is going to take input my entire array and the value n, and here I'm going to say okay, let me do one thing. Let's say max XOR is going to be 0, and then I'm going to iterate over all the elements of the array, and I'm going to insert those elements one by one in my array. So current value that I have is going to be input of I, and I say okay, insert this value in the try, and I also say okay, find out what is the current maximum XOR you can make using this element. That is going to be given by max XOR helper, and you give the value here. And maybe just to test our code, I'm going to print current XOR, and another variable that we have taken is max XOR. So this will give us maximum of all XORs. So it will be max of current max XOR and whatever is the max XOR till now, it would be max. So finally from here I can say return max. So I think this is complete, and now we have two errors. Okay, semicolon, and yeah, this should be commented out. So finally what we need to do is we need to create try, and we need to output the final answer by giving the input array. So let's build the code. Okay, we should also give the value of n. The number of elements is 6 in this case. So you can see we are getting this is the output of the current XOR, and find the last value is the max XOR. So we can see this is going to be 28, and let me tell you why this is the answer. So in the beginning you have a number 3 and you insert 3 in the try, so it's like 0 0 0, lots of zeros followed by 1 1. So you say okay, I insert this thing in my try, and I give the value as 3, and I say okay, give me a number, give me the result of 3 with this try. So this result would be 0 because 3 will get combined with itself, it will give me a number 0. Next time I say okay, insert the number 10 in the try and give me a maximum XOR. So you can see 3 XOR 10, it would be 3 XORed with 10, so 0 1 1 followed by 1 0 1 0. So this number would be nothing but 1 0 0 1. So this number is going to be 9. So you get this answer. Next time I insert the number 5 in the try, and I say okay, try to find out the maximum XOR with the numbers you have inserted so far. So obviously it would be 10 XOR 5, that is going to be 15. Okay, and next time I say okay, insert the number 25, and it would be nothing but it will pick one of these numbers, and in this case it is I think 25 XOR 5, that is going to be equal to 28. And you can see this is the highest number that we can make by XORing two elements in the array we have. So this is what we do here in the max XOR loop. So you pick a number from the array, you insert it into the try, and you calculate what is the best XOR you can make using the current number and the numbers you have so far. So this is what we have, and this is just to update the largest XOR that you have seen till now. So I just comment this out, and this completes our code. So I hope you guys got an idea, and this function was bit tricky to understand in the first sight, but I hope you guys would be able to go through it. So basically I will just give you a quick recap here. So what we do here is whatever number we have lots of zeros and ones in the try. So whatever number we get, we try to extract all the bits of that number. So if you get a 0 here, Starting from the try, you try to find out a branch where you have a 1. Let's say next number is 1 here, so you will go to this branch. Next number is, let's say, again 1 here, you go to this branch. So you can see 0 1 1 when XORed with 1 0 0, this will produce a maximum XOR. So this is what we basically do in this approach. And now you can understand why a try data structure is so useful to solve this kind of a problem. Hi everyone, so now we are going to discuss very interesting problem statement. It says you need to find out a subarray with maximum XOR. Okay, so that means you need to find out a smaller part of the array. Let's say this is the subarray, and you will XOR all the elements, and this XOR should be maximum. Okay, now let us discuss how we can solve this problem. So brute force way would be you pick out all subarrays from I to j, and then you find out XOR of those elements by iterating over them, and this would eventually take order of n cube time. Okay, so another way that we can do is, what we can do is we will again pick all the elements I to j, but in order to compute the XOR we can actually do something simpler. Okay, so something like a cumulative XOR. So cumulative XOR would mean that if you have this array, let's say 3 10 4 25 2 and 8, so what you can do, you can basically store 3 here you can store 3s or 10, here you can store 3s or 10s or 4. So basically at any given index I, you store XOR of all elements till I. Okay, so this can be built in order of n time, so you can just build this array in O of n time. So XOR of all elements. So like you find out the sum of a smaller subarray, you say okay, if you want to find out sum of this part, so it would be sum till this point minus the sum till this point. So in cumulative XOR, if you need to find out XOR of, let's say, some range L to R, let's say you want to find out XOR of some array L to R or I to j, let's say this is L to R, so you can simply say it is nothing but it's cumulative XOR of till the point R XORed with cumulative XOR till the point L minus 1. Okay, so what would be cumulative XOR till the point R? So it would be nothing but 3 XOR 10 XOR 4 XOR 25, and if you XOR it with the point L minus 1, so that XOR is nothing but 3. So you will see this 3 will cancel out and you will get only this much part of the array. So what you can do is you can build a cumulative XOR array in order of n time, and then for all the subarrays L to R you can check out the XOR value with the maximum value. Okay, so that would be take order of n square time. So basically we reduced the time to iterate over every subarray by doing some pre-computation. Okay, third is we can actually use our trick that we have learned in the last video. We can actually convert this problem into a problem where we need to find out two pairs A and B whose XOR is maximum. Okay, so what I'm saying is, from this array build another array in which you have cumulative XOR. Okay, so I'm just writing cumulative XOR. So first element is 3, next element is 3s or 10, next element is 3s or 10s or 4, next element is 3s or 10s or 4s or 25, next element is 3s or 10s or 4s or 25s or 2, and so on. So let's call this element as A, let's call this element as B, C, D and E. So now you can say you have another array in which you have these elements A, B, C, D, E, F, G. So if you basically find out the max pair XOR, so basically pair of elements with the maximum XOR, so what will happen is, let's say you pick E and you pick B, so basically this will give you a XOR of a subarray. So let's say you pick E, this is E, and if you pick B is another element. Okay, when you XOR these elements, when you do E XOR B, so it will basically cancel out the effect of 3s or 10, and what you will get is you will get a XOR of a sub array. So basically, from the updated array, you need to apply the same approach that we have discussed in the previous question, in which if you find out the max pair XOR of two numbers from a given array, you will end up getting a maximum subarray XOR, and that is happening because we are making a cumulative XOR array. And when you XOR two elements from the updated array, so it basically gives you a subarray like we have seen here. So I hope you guys got an idea how to solve this problem, and this would even reduce your time complexity further. Making the cumulative XOR array would take order of n time, and finding the max XOR pair will also take order of n time. So from n cube, now we have reduced our problem to order of n. So use your try knowledge to implement this solution, and most of the part we have already implemented in the last video. The only thing that you need to do is to compute this cumulative XOR array. That can be done easily. So you can say cumulative XOR of 0 is same as array of 0, and for all other elements from I equal to 1, I less than n, I plus plus, you can simply say cumulative XOR is going to be equal to XOR with the current element, that is array of I. Okay, so XOR equals to, so I'm using this operator. So that's all for this video, and thanks a lot.